All right. Hello. Welcome. There are three of us hosting today, it looks like. Cora could tell you we've been on together for like the past hour.
Hello. Welcome.
Oh, no.
There are three of us hosting today, it looks like.
Echo.
Cora could tell you we've been on together for like the past hour. Hello. Welcome.
Oh, no.
There are three of us hosting today, it looks like.
Echo.
Cora could tell you we've been on together for like the past hour.
Wait, was that me?
Is it?
Sorry, I think I had too many windows open.
Yeah.
We're good. Yeah.
Oh, yeah. It's gone now.
I thought
it was. Woo! Yeah.
So.
Yeah. Hello from the Netherlands. Hi. Lisa's hi to the cats.
Hi,
so
Lisa.
I was saying that Cora and I have been here an hour getting ready for the stream, and the cat's been fine. And then now the second we start, she wants some attention.
The cat knows when the cameras are actually streaming.
So I'm in Texas, and it's snowing here, or it did snow a couple days ago, but there's still snow on the ground. It's in the 30s. We're not used to this at all. And the cat usually goes in and out, but now she's like, it's cold and she's confused. So a lot of times today, she's been kind of like up in my face, like what? Like she thinks because I have control over everything else in her life that I should have control over the temperature outside. She wants me to fix that for her.
While you're at it, Whitney, you could make it a little bit warmer in New York too.
It's not global warming. It's just me being a jerk. Yeah. So hi, hello. I'm Whitney. This is Cora. We should introduce ourselves, I think, before we dig in on the learning.
Yeah.
Do you want to go first?
No, you go first. And,
okay.
I'll keep an eye out also on chat. We've got people joining from Israel, from Colorado, from the Netherlands. That's awesome. So yeah, go ahead.
From Israel. Hi. So my name is Whitney. I'm relatively new to tech. I went to a boot camp in 2019. I graduated in October of 2019. And at the boot camp, I learned full stack web development. So I actually wrote my very first line of code in January 2019. I graduated. I worked really hard that year. I graduated 10 months later. And then I immediately got a job as a cloud developer where I didn't use any of that web dev knowledge at all. So I started over again. But I work really hard at learning. I study every day. I have a certifiably medium amount of Kubernetes knowledge because I have a KCNA certification. And I'm an advocate here at VMware. And I'm honestly meant to represent new learners and make myself vulnerable and be here and let everyone know that like they're not the only ones trying to wrap their head around this new material. It's hard to learn, and but it's fun too and rewarding. And there's so many great people in the Kubernetes community, such as Cora.
Yeah, I often find that I don't know many things, but I cannot say that it's from lack of time in the field. Maybe it's well spent. Must make more work.
I can speak to your thirst for knowledge and your willingness to learn, though. I've seen you learn a lot just in the 8 months I've been in this position.
There's so much to learn. Hey, Spencer. Hey, KR. We have Ben from Romania, Ian from Wales. So exciting. I want to travel to each of these places, San Jose, Denmark, Helsinki. Wow.
Thanks, everyone. This is amazing.
Yes. So I'm Cora Iverclyde. I'm on the same team as Whitney here at VMware. We're both developer advocates. And this is my second time co-hosting TGIK. So I'm really thrilled to be here. 8 months goes by fast.
It does. I started in June. Yeah.
So I guess we've got, we're going to follow the normal format, which is a little bit of news of the week. There's a HackMD link, which I guess we should share that.
Yeah, let's do that.
And if you have any news that you want.
You got it, or shall I share it?
If you have it.
I do have it. I'll put it in the chat right now. Here we go.
Denmark is probably lovely. I almost spent a semester in college in Denmark, and then I didn't. But one of those almost in my life. If I would have done this, how would my life have been different?
Yeah, I have a son who's 22 years old, so I had him when I was 20. And it's been very rewarding to be a parent. I'm all done now. I've been there, did it. He's an adult who lives in California. He's graduated college. But I feel like in my life, I missed out on global travel. That's the big thing I sacrificed by being a mom instead of, yeah. So I hope to make up for that. If the world lets me and opens up, I'm hoping to visit everybody's city.
Exactly. Yeah. Here's your travel list right in the TGIK chat right there. Let us know in chat also if you've played with kpack already or cloud native Buildpacks. If there's anything specific you want to get out of today that we can spend extra time on, let us know. And yeah, so the HackMD link is there, and we picked out some stuff that we thought was maybe interesting for news of the week.
Mm-hmm.
I don't know if you want to.
I can get started with that. We're going to take turns announcing things. So if you're a Kubernetes contributor, Kubernetes is switching over to Easy CLA. And so according to a GitHub issue that was brought to my attention, the migration is scheduled to happen this coming weekend. So if you have any CLA issues, now you know why. I don't know what you do about it. Hopefully the GitHub issue.
Until you found this issue, Whitney, I didn't even know what a CLA was, but you've been, despite your short time in the industry, you managed to become a Kubernetes contributor.
Yes, I got involved with the SIG docs. So I go to all the SIG docs meetings, and it's been such a warm and welcoming community. So I've done a little bit of fixing up just as I learned from, okay, so for this job, I felt like I wanted to understand all the vocabulary around Kubernetes. So I actually went and made flashcards of all of the glossary entries so that I could work up my vocabulary and understand at least the gist of what everything is. So as I found things that were unclear to me in the glossary, I fixed them. And so that's how I came to be a Kubernetes contributor. But SIG docs is great, and I understand all the special interest group is what SIGs are. Yeah, the SIGs are wonderful.
So you needed the CLA.
Mm-hmm.
You needed a contributor license agreement.
Yep.
In order to do that, and so now there's, I guess that's the update.
Yeah, I believe the Easy CLA helps organizations. Like I had to go through. It was kind of complicated to be able to contribute the first time, especially as a VMware employee. And so I think the Easy CLA is meant to make that process easier.
Let's see what's next on the hack. Do you want to share the screen maybe for the hack?
Sure.
Let's see. All right, so the next thing, there was an Argo CD vulnerability that I don't know all the detail about it, but I know that it's by way of Helm. Like somehow Helm was opening up a vulnerability with Argo CD that was kind of like a day zero vulnerability. And so it was discovered, I believe, yesterday, but there's already a patch for it. So if you're using Argo CD, make sure you go out and grab that patch and patch your systems. That sounded important enough.
It does. And according to Last Week in Kubernetes Developments, the release engineering published an emergency extra update. So I actually don't know what any of this means, but the word emergency made me feel like I should include it here. So users who use custom resource definitions that rely on the field X Kubernetes preserve unknown fields true should update to 1.23.3 immediately.
So yeah, so a couple of security warnings there, which actually bring us to the next one. So there's a project called,
we have a question in the chat. Is kpack like Google Kaneko build containers in a container?
We will, it works a little bit different. So the idea, the purpose of kpack is to build containers from code. It works a little differently than Kaneko. So we will see It's not a silly question at all. So I would say, I don't know if I'm saying your name right, but Rajaselan, if we don't have a good answer, if you don't feel like that question was answered after we start looking into kpack a little bit more, then let's bring that question back up at the end. I think Canico, I'm trying to remember as I'm saying this, if Canico relies on a Dockerfile, if it's using your I think Canico requires your Dockerfile and then builds your app from the Dockerfile. And if that's the case, then kpack does not require Docker files. And it has a much more sort of like a very structured approach, which we'll explore. So I think that we will answer that question in more detail as we go through this.
That was perfect.
Cool. So yeah, so speaking of, so we have the Argo CD vulnerability and we have this other super onerous sounding statement that if you use these extensions, you should upgrade. So, so we thought it also would be worth mentioning that there is a project called Alpha Omega that was created to design a secure global open source supply chain. And that was, I think that one might have been already announced back in October, but I think it was Google and maybe Microsoft that committed more money to it. So it was kind of like raised again this week. Hi, Thindo. It was kind of raised against this week in some of the Kubernetes sort of like weekly newsletters. So there's a link there to also if you follow that link, so the HackMD link is in the chat. So definitely if you want to find the links that we're sharing on the screen, you can go to the HackMD link, which is right here. And so there's a webinar. If you're interested in that topic, if you're interested in learning about what they're thinking of in terms of designing this concept of a global open source secure supply chain, there is that webinar on February 16th coming up that you can join.
We have another question in the chat, Cora. Can kpack builds be integrated with Gradle or Maven plugins?
So kpack itself does not use Maven and Gradle plugins, but the technology that it uses to build an image can also be accessed. So kpack is kind of like an alternative. Kpack is sort of like, think of it as a portal. It's something that allows you to use the backend mechanism. And this for Spring Boot, the Maven and Gradle plugins are alternatives to kpack, so they will build ultimately the same image as kpack. But kpack itself, when it's running in Kubernetes, it's not going to directly use the Maven or the Gradle plugins.
They both use cloud native Buildpacks. Yeah, cool.
Yeah, right.
Another piece of news. Are you finished with your piece of news with the Alpha Omega? Cool. So just a reminder that the call for papers for the CNCF hosted co-located events at KubeCon and Cloud Native Con Europe this year are due soon. They're due in 10 days on February 14th. So get to writing.
Yeah. And if you're thinking of submitting a talk and you haven't done it before and you need some encouragement, you can DM me. You can probably DM Whitney. I'm going to offer her up, but you can certainly DM me.
Totally. I mean, I've never been accepted to one myself, but I'll do the best I can to help you for sure.
We'll help you. We can help with your abstract, whatever you need to get the courage up to do it.
I can help with courage, actually.
Right. And then the last piece of news before we get started on kpack is just that this documentary actually came out in January, but I think the second part was announced maybe late last week, so we thought it was worth mentioning. So if you are, this weekend, if you don't have plans and you can't find something to watch on Netflix, there's a 2-part documentary by Honeypot that's really good on Kubernetes. With a lot of the hosts that you see here regularly on TGIK are interviewed as part of that documentary to kind of tell the story of how it started and the thought that went into it and how things happened. And so it's very nicely done and I highly recommend it. So that being said, I think we should get started on kpack. So thank you, Rajaselan and Alexander for the questions so far.
Yeah.
And so let's get started.
The chat participation is super fun. I appreciate y'all. So the first question is, what is kpack?
What is kpack? What is it for? Why would you use kpack? So kpack, it's a project that was created, I think it was 2018-ish. Cloud native Buildpacks were created in 2018, which is a sort of a very structured way of generating OCI images. And kpack is one tool that you can use in order to leverage cloud native Buildpacks to generate images. So the project itself, I believe, also dates back to 2018. In fact, Joe Bita did a TGI episode on kpack a couple of years ago. And so what we're going to try to, I mean, we'll cover the topic as in its entirety anyway, but probably in the section where we're doing hands-on stuff, we'll try to probably do things in a way that leverage things that were released since Joe did the last episode. So you'll see something a little bit different from the last one. But yeah, so yeah, let us know in chat also, like, how are you normally building images? Do you use dockerfile today, or do you play with cloud native Buildpacks? And if you are playing with cloud native Buildpacks, do you use have you used kpack, or there's also a CLI called pack you can use, or as Alexander mentioned, Gradle and Maven plugins if you're using Spring Boot. Those are all different ways to use cloud native Buildpacks. And kpack is the one that's oriented towards really like high scale situations, because kpack is something that you install into a Kubernetes cluster, so it can operate at scale and it can operate centrally and serve a lot of development teams or a lot of developers, and it'd be easily managed by an operations team essentially. So it hits all those kind of like use cases as it leverages cloud native Buildpacks to build OCI images in a really structured way. So does that make sense? Yes.
So could you boil it down and say, like, it's a way to build images leveraging Kubernetes? Or if you know your images are going to live in a Kubernetes cluster, that would be a good use case. Like, who are kpacks? Who is the user for kpack?
Who's the user for kpack? So I think, so one aspect of a person who would be interested in using kpack is a person who's interested in building images in a more structured, in a better way. Like Dockerfiles, and I can see several people in the chat are saying they use Dockerfiles. A lot of people have Dockerfile templates. Their company has created Dockerfile templates. Yeah, so that is super common. Dockerfile is the oldest way to build images. So you are going to find that a lot of people use them, and it's the one that most people are familiar with. So if you have an application and you have to build an image, the first thing you might think of is to build a Dockerfile. Buildkit and Jib are also, yeah, okay, yeah. And so the thing is that every Dockerfile that you're using is like a script that you wrote by yourself, right? Like you're already maintaining your code, you're already maintaining your app. If you add a Dockerfile to your Git repository, that's one more piece of essentially custom code that you have to maintain it. And as Alexander is saying, and for example, in his case, his company is using Dockerfile templates. So they have, so in that case, there are organizations that have, assigned the responsibility over Dockerfiles to a centralized team that can then put them into a Jenkins or something like that, so that everybody's using the same ones. But it's still, every Dockerfile is still a custom script, and it's still going to be different from the ones that your another company is using, or anybody else is using, because each one is one that you wrote. So cloud native Buildpacks was an attempt to solve that problem of saying we can build better practices and have a standardized way to build images, and kind of like make it part of the system that things will work out of the box and that they'll be easy to share. Yeah, so that was kind of like, and we can talk about sort of the internals of cloud native Buildpacks, and it got rid of some of the disadvantages of Dockerfile. Like for example, when you build an image with a Dockerfile, if you have an operating system vulnerability and you need to change the operating system in your image, that means that you have to go to the very first line in your Dockerfile, the one that says from base image, and change that line. And when you change that line, because your Docker image is composed of layers, with Dockerfile, if you change the first layer, you got to throw away all the rest of the layers and rebuild the image, which is slow. You have to do it one by one, starting from the source code. And you're also rebuilding parts of the app that didn't change when only the operating system changed. Why are you rebuilding the code, recompiling the code, right? You might be introducing changes inadvertently. So that kind of thing is something that Cloud Native Buildpacks just takes a very different approach and organizes images in such a way that you can swap out layers without having to rebuild the whole thing. They're not as sensitive to like the order of the commands in your Dockerfile and things like that. And then there's also an opportunity because you're just reusing logic that's already built into this project, basically. You don't have to write yourself all of I mean, when you build an application, you can build it very simply, right? You can just say, like, let's say you're in Java, right? So you just say Maven package, and then you move your jar file into your image. And that's fine, it'll work, but it doesn't have any like extra efficiencies that you could add in terms of maybe memory management or layering things better, or anything that you would build into the app. You're probably not going to do it in a Dockerfile. So Cloud Native Buildpacks give us a much more sophisticated way to build images. So that's one. So I guess to answer your question, like one reason to use kpack, or one reason to use anything that uses Cloud Native Buildpacks, including kpack, is that you want to build better images and you want less responsibility over managing the customized way to do it. And then why kpack specifically? Because your alternatives are a CLI. The same way you use Docker build, you can have a CLI experience with Cloud Native Buildpacks. Or if you like Maven package or Gradle build, you can use those commands and also use Cloud Native Buildpacks to generate an image. So you would use kpack because you have the use case where you need to support probably a larger number of development teams and you want a more autonomous way where you can just install something in Kubernetes that will be watching. So instead of the imperative, like, here's my code, I'm going to drive it from a CLI command, you can install something that is going to be polling all of your Git repos and building images automatically. So all you have to do is a Git commit, and then this operator that's sitting in Kubernetes watching your code will automatically publish an image to a registry that you can then deploy with your patched Argo CD installation. Yeah.
So there are a few things I'm hearing. One is I picture like a Dockerfile being like a parfait or something with a glass cup, and it has all the layers of deliciousness, and and then like a build pack doesn't have the sides. So like if you wanted blueberry jam in your parfait instead of the raspberry jam that's there, and if you had a Dockerfile, you have to throw away everything on the top and rebuild your parfait. Where somehow with kpack and with Cloud Native Buildpacks, you can just remove that layer and yeah. And it also just stays pristine. Yeah.
And so you might use kpack just because it's delicious.
And then kpack, I just want to drive home too that I think one of the big benefits that I know is that watching, and I don't know if any other of the Cloud Native Buildpack tools do this, but I think it's so cool that it pulls the Git repo for you. So you not only do you not have to maintain a Dockerfile, you don't even have to make a Dockerfile. It's just watching, and then the image just gets built. And I think that seems like a huge value. And then I imagine if everyone's making their custom script and there are all kinds of different Docker files, it seems possible that the end image could be not very different necessarily, but not standardized.
Yeah.
If from the same code base, you could build different Docker files and get different images.
And then put yourself in the shoes of the operator in that scenario. Like you have all these developers using different Docker files, and they're like, "Here, you maintain this. They're secure. We Googled how to make our Docker file secure, and we're sure, And then you're the operator responsible for saying, like, okay, I'm going to let this into production because they said it was secure enough. Like, who knows?
So that it's repeatable, like it's perfect, it's reliable, it seems pretty great. We're getting some good parfait humor in the chat right now.
It's going to be all about food.
Parfait straw. Yeah.
So a couple of the questions. Cuddle exec into a build pack. So what you can do is when we'll see this, when kpack is building an image, the build is happening inside of a pod. So you can Cuddle exec into that pod if you needed to, as long as that pod is still up, right? Like if your build is taking long enough that you have time, it's just a pod. Well, having said that, because it's a pod, but the process of building an image is composed of like different steps, and each step is happening in a different init container. So I guess you just have to Cuddle exec into the right container. But so I don't know if you would need to do that very often, but it's a build happening in a pod across a series of init containers. So it's no magic. And then kpack work behind corporate. I mean, kpack, you're installing it in your Kubernetes cluster. So as long as the access from kpack to your registry and to your Git source code is all behind your corporate proxy, then it should just work. It doesn't. It's living inside your Kubernetes cluster. So however you configure your cluster. Are there any application binary interfaces for Windows apps? That's a good question. I don't know if that's a good question. We have to look up. So do you mean something a tool that you can use on your Windows machine to build images, or something to build images that would have like a Windows operating system in the container image? Like, is the Windows as the machine you're working on, or what you want in the image? I guess if you can, we can keep talking about that one. Okay, so should we try it out? Should we?
Yeah, I think yes. So we're gonna install kpack next.
Yeah, so let's install it first.
All right. I'm going to click on the install kpack link. Yes.
Yeah. So, okay, so it's just a Kubernetes project. So like anything else, you have kubectl apply and the release file that you would download from the website. But because as I mentioned, Joe did an episode on kpack a couple of years ago. This is the way he would have applied it in the episode. This is the way he would have installed it in the episode. Just kubectl apply and the YAML file that you download from the GitHub site for kpack. So what we're going to do a little differently is if you've been watching recent TGI episodes, you've probably seen Timmy and Josh and others talk about Tonsil Community Edition. And very recently, I think it was 1 or 2 weeks ago, kpack, a package. So Tonsil Community Edition is a tool to provision clusters, and also a tool that helps you install additional applications that you would normally need on your Kubernetes cluster, right? If you've heard people say Kubernetes is a platform for building your platform, that means that a vanilla Kubernetes is not enough generally. You need to install things like kpack if you want to build images, right? Or like, I don't know, Knative or Contour, different projects that you need to make your Kubernetes cluster more full-featured. And so Tonsil Community Edition, and there's a link in the chat, is a tool that helps you build up that cluster. And so kpack was recently added as a package to Tonsil Community Edition. So we're going to go through the installation using that approach instead. Thanks, Tom.
So we got an answer to the question before from Tom, who works on the kpack project, I believe. Yeah. Kpack can build Windows images where the stack OS is Windows, but that is a beta feature at the moment. All right. So what is I really have no, I'm leaning on you hardcore. I have no idea how to.
We're going to do this. Okay. So basically, okay. So what do we have on, so on your computer? So Whitney and I made sure that we have a cluster running that was installed with tonsil Community Edition. But right now, there shouldn't be anything on it. So if you do first of all, you can do like a kubetx just to show we're pointing at a cluster, or kubectx, I'm sorry. So we're pointing at a cluster. So the one that we provisioned is you can provision different kinds of clusters with tonsil Community Edition. It can be, you can provision a cluster on a public cloud like AWS or Google or Azure, and or you can do something locally on your Docker. So we're working locally on Whitney's machine on Docker. And the other choice you have with tonsil Community Edition is to configure like an unmanaged single cluster, or to create a management cluster and then use your management cluster to create worker clusters where you're actually going to deploy things. But we didn't need that. So we just went ahead and created an unmanaged single cluster running on Docker. So you can see it actually leverages kind in the background. Kind TCE is the context, the cluster we're pointing at. So we can also do a QNS and show. So that
kind is an acronym, right? It stands for Kubernetes and Docker. Yeah.
Kubernetes and Docker, right? Yeah. So it's running locally in Docker. Yeah.
And what do you want to run?
QNS will show us the different namespaces in the cluster.
I'm sorry, I didn't hear you.
Kubenes, K-U-B-E-N-S. Did that not work before?
Yeah, it did.
Reboot? No. You reboot your machine?
I did actually. During the
Docker running? Is Docker running?
I guess not. Sorry.
No problem. Let's see. Any other questions? Yeah, I don't know if not to put you on the spot, Tom, but if you know more about the TBS versus kpack, I think there's more support in TBS to swap out the OS. I believe that was a thing with TBS. So TBS, for those who don't know, being the commercial version. So kpack is the open source version, and tonsil build service is the commercial version of this product. So it is everything kpack plus a few extra things that would be interesting to organizations, but not essential to getting value out of kpack if you're not looking for that. Okay, so did that work? Okay, good. Okay, so you can see that in this cluster, there's we don't have a kpack. We haven't installed kpack yet. There's no kpack namespace. There's just regular namespaces that you expect out of vanilla Kubernetes, plus a couple that have to do with tonsil Community Edition as a system. So the core stuff and the TKG system, which helps to provision clusters, and then this package repository namespace, which it holds the package repository that includes kpack. So here we want to type tonsil package available list, I believe is the command. So here we're just asking this tonsil Community Edition cluster to tell us what packages are available in this repository. None of these are pre-installed, but they're available for us to install. And so you can see there that we have the kpack package available to us. So, and just if you're going to try this at home, I'll just warn you that if you're doing this standalone cluster, you just have to upgrade your package repository to version 0.9.2 to get kpack in it, because kpack was such a recent addition to this package repository that you just got to make sure in the CLI you can do a tonsil package repository update command, and you just do it with version 0.9.2 instead of 0.9.1, which is what is in there by default. So so once you have that, then what we really want to do is go to the tonsil Community Edition website, because the instructions that we're looking at on the screen, which are the ones from the kpack GitHub repo, are the ones to normally, the way you would install, right, Cuddle apply this YAML file to any cluster. But since we're going to do this with Tonsil Community Edition, we actually want to check the Tonsil Community Edition documentation. And so you can see there should be a link on the left there to say that says packages a bit lower down. The installation on this page refers to the actual installation of Tonsil Community Edition, which we did. Yeah. So now we're in the packages section, and we can find kpack to be there. Yeah. So here, so now, so that's the other nice thing about Tonsil Community Edition is that it gives you this resource with information about all of the packages that are part of this particular package repository. So it's a little extra help, I guess, in terms of like getting you to help install. So one thing that we see here is that if you read through the doc, you'll see there's no prerequisites for kpack. You can just install it by itself. And there are some configuration parameters, which we will use a few of them. And also there's this mention of a CLI, right? Somewhere in the middle, it says this assumes that the kpack CLI has been downloaded. So that's another new thing that I don't think that was around 2 years ago when Joe did the last session on TGIK. So I would say let's start by installing that CLI actually.
Okay. I don't see where you're seeing that.
Right in the middle of the page, it says Homebrew.
Okay.
Yeah, there. Yeah, let's follow those links.
Okay, got you.
Let me check the chat. I'm super grateful for everybody who's helping to answer questions in chat.
Yeah.
Yeah, so I mean, Waleed, VMware's trying to convince you to use Tonsil standard. Well, one great way to figure out if you want to be convinced is to use Tonsil Community Edition, because Tonsil Community Edition basically has it's like an unrestricted, no strings attached, OSS free, all of the OSS that's part of Tonsil commercial. So evaluating Tonsil Community Edition is a great way to figure out, if you want to go along with those suggestions or not. Okay, so awesome. Okay, so we've got the KP CLI installed. So now we want to do, okay, so let's go back to the documentation. And the other thing we're going to need is, of course, the documentation for Tonsil Community Edition. The middle one, yeah.
Sorry, I thought I clicked it.
Okay, so if you scroll up just a little bit, we'll see what are the parameters that we might have to supply. We're not going to be using Proxy, so we don't need the bottom three, but the top three are important. So we need a default repository, and we need the username and the password, basically, right? Mm-hmm. So what you want to do is create a file and put these three values in the file.
Okay.
And you can call that file anything you want. You can call it, for example, kpack values.yaml or something like that.
Okay. Touch is the right word, right?
Yeah. Yeah, and then whatever. Yeah, you can use VI, you can use whatever editor you want. And so, okay. Yeah, so just, you can literally make sure you type the I to insert.
Yes.
Okay, and then you can copy and paste those three values. And so that, okay, so for this one, then add a colon because this is a YAML. And then here we're gonna wanna put your, so we're going to be using Docker Hub is what we decided?
Yes.
Okay, so then it would be your, whatever your Docker Hub, Wiggity Whitney, was that your, or you could just, actually Docker Hub Docker Hub is usually the default, so you don't even need that when it's Docker Hub. If it's GCR or something else, you do need, but you could literally just put your username and then slash, and then, you know, slash something, maybe KP or something. TGIK is fine, yeah. This is what KP is going to use to move some images into your registry. We have an opportunity to specify different repository names later that are going to go under Wiggity Whitney, but so this is one. Okay.
Okay.
Then so then the next value.
We do have some questions coming up. Can we distribute app traffic across different clusters on different IaaSs?
So kpack is a per cluster installation. So if the question is specifically about like if you can distribute the builds, because basically the only thing that kpack is doing is it's looking at where you say your source code is, and when there is a git commit, then it will build the image, and it does that in a pod. You can leverage all of the resources within your cluster to do that. If you can create the resource that points to your source code. You could create them in different namespaces, so you can make that spread out, I guess, somehow. But it's not going to spread across a different, like one kpack is not going to reach out to a different cluster to trigger a build to happen on a different cluster. So from a single kpack perspective, no, but you can install kpack on AWS or on vSphere or on Google. Like, it doesn't care. You just need Kubernetes. So you could do it across different ISs in that sense. Let's see. All right. So in the meantime, let's build up this file. Do we have the repository username?
I think I just built it out on my own because I saw the password coming. What's going on? So
if you do like a head -n2, you could type head -n head space -n space 2, and then the name of the file, and that'll just give us like the top 2 lines of the file.
Okay.
So as long as the password was the 3rd line, we should see. Okay, so we'll assume the 3rd line. So would have been kp default repository password, and what you actually used was an access token. Is that correct?
Yes, that's correct.
Right. Okay. So yeah, better practice is if you're using, depending on your registry, what it gives you. But for Docker Hub in particular, we can use access tokens instead of our password. So now when we install kpack, it will read this information and it will populate. Actually, I think it populates a config map. So that I think the KP CLI is going to use this information. So okay. So having said that, let's go ahead and install it. So the installation command is going to be a standard command for when you're dealing with Tonsil Community Edition. So, I mean, we know because in the documentation, we can see that on the left-hand frame, if you scroll up a little bit, like there was only one version of kpack because kpack was just added, right? So under packages. But you could also, yeah, so under packages, under kpack, there's only going to be one version of kpack. Some of these other products, 050, which is the latest. Some of these other products have different versions that are included in the repository, but here we only have one. So we can go ahead and say tonsil package install. Or why don't we do a tonsil package available? And I think it's a list. And then type kpack.community.tonsil.vmware.com. I think that's the right command. I hope. Yeah.
I know. Yep.
Kind of the same information, right? You can just query the cluster and say like what versions of kpack are here. So now let's go. What's that?
What you got for me? Just talk to your cluster.
Yeah.
That's what I do.
Exactly. Tell me what you have. Yeah. Okay. So now we want to install this. And so so this is for any package. There was like a list of 12 packages. We saw that before, right? Something like that. So for any package, you would just say tonsil package install kpack in this case. We'll name it kpack. And then you say -- package - name. And then you can copy paste that kpack community tonsil VMware com.
Not the version though.
Not the version yet. No. Perfect. And then -- version, and then the version number, space, and then the version number. And then because we do have a configuration file, then we want to say -- values - file. And yeah, and then your kpack values file. Yeah, that should do it.
Okay.
Try it. Okay, so pretty easy, which is cool because if you did the install the regular way without Tonsil Community Edition, like you can see here in the output, it's saying it installs the package. The namespace is also part of the, but I think it does like so the service account and the secret is automatically creating those. So it's just like kpack installation is not complicated regardless, even if you're just doing the regular kubectl apply in the release file. But doing it this way does remove like 1 or 2 steps of like the secret and the service account, I think. So it's a tiny bit easier.
We have a question in the chat.
Let's see, which question? The last one? Okay. The config options have proxy settings or corporate proxies. Tom, I'm going to reach out to you for this one.
We should read it. The config options have proxy settings, but corporate proxies tend to intercept traffic and use private root certificate to do this for HTTPS traffic. So is there a way to add this root certificate? And that is something we don't know. We're hoping that our friend Tom from
I
Buildpacks
think Tom maybe answer this better than I can. Oh, hey, Tasha's here. So let's see if Tom can help us out, and if not, we can do a little more digging. But I feel like we're going to get the best answer if we give him a second.
Yep.
But good question, man. Yeah, so this just takes a second. Okay, so while this is going, what else could we do?
I'd be interested. So I would like to talk a little bit about, just for people maybe who are earlier on in their journey like me, like we've said, kpack is a tool for cloud native build packs, but what are cloud native build packs? Like, that's what I think we should maybe go into about a little bit, because I found cloud native build packs a little bit difficult to understand at first, because build packs, the build packs are called build packs, but also build packs, when you refer to the life cycle, you could also be talking about build packs. When you refer to the tools, you can also be talking about build packs. And so I just maybe wanted to disambiguate that.
There's not enough words. Use them to refer to different things.
Right?
Hey, Glenn. So, yeah, should we pull up we can pull up the buildpacks.io website, and we can pull up the Paketo. Is it
okay.
Paketo.io?
Yeah, let's go to the Buildpacks website. But before we do, we have some more conversation in chat. So Tom came on to answer Martin's question. There's actually an issue to add a certain injection webhook to TCE, meaning Tonsil Community Edition. I'm currently working on that, but I don't have an ETA yet. So it's coming. And then Alexander has a question. Where does
kpack, yeah, so where does it cache? So kpack is going to use a persistent volume claim for the cache for a build, so that if you build something once and you download, let's say it's a Java app, so you build it once and you're going to download the JDK, that's not going to go in your image. That's going to go to production, right? So you don't want to have to download that JDK every time you build. So that has to be cached somewhere. So kpack in particular will cache that in a persistent volume claim. You can, if you didn't want that, you could disable that feature, which just means that your builds will take longer because you'll have to download it every time. But it uses a persistent volume claim to do that. Cool. So, all right. So we've got kpack installed. So we could do a kubeNS again, for example.
Oh, what is it again? KS? KP?
kubeNS.
Oh,
Cube.
Okay.
Cube.
Like we're getting our namespaces.
Exactly. So now we have a new one. We're not pointing at it. We're not supposed to be pointing at it. That's good. But there is a kpack one. And you could do like, if you want to do a kubectl get pods in -n kpack, for example. You could look at what's under the hood.
All right. Tell me again what to type, please.
Kubectl get pods -n kpack. Yeah, more builds. Yeah, right. A longer coffee break. Exactly. So, okay, so you can see that there's a couple of pods running. So this is like the internal, this is like the actual product, right? Whatever's in the kpack namespace is like what was installed by kpack for the product itself. We won't be adding stuff to that namespace, but you can see the controller is there. So if you ever really like something was not working and you thought maybe like it's an error within kpack, you could come to this namespace and check out the log for the controller. That would be maybe something would help you out there. But we're going to be working in just the default namespace to actually build, to create the resources that are going to build our application. KP doesn't support this yet, but if you kubectl apply an image resource, you can use a registry image cache instead of, oh, cool. Okay.
Pretty cool.
All right. So yeah, so I think that's the other cool thing about cloud native build packs in general, that they really leverage kind of like the latest functionality and features of registries. And they offer a pretty sophisticated sort of like caching capabilities by leveraging the fact that OCI images are really manifest that point to layers, and that OCI registries can enable some sort of advanced caching. And so the Cloud Native Buildpacks project in general tries to take advantage of this thing. So it's nice to see even newer things coming up in that sense. Okay, so we've installed kpack. We do have your pending question, Whitney, about getting more into Cloud Native Buildpacks in general. Yep. Let's do those maybe in parallel. Maybe as we move forward with kpack, we can talk about what does that mean in the context of Cloud Native Buildpacks in general. Okay.
Yeah, that's great.
Okay. So since I know that many people in chat have mentioned that they work with Docker files, Docker files are always the first statement in a Docker file is always from something, from a base image that has only some kind of Linux or whatever, or from a base image that has the runtime for a Node app or for a Java app, right? You can choose your starting point, and you can go to Docker Hub and maybe see what their like the certified images are, or maybe your company has like a certified one that everybody has to use that one. So in the case of Cloud Native Buildpacks, so I would say, let's open up those two pages actually, buildpacks.io and paketo.io. So in the case of Cloud Native Buildpacks, so here's the buildpacks.io website. And this is the project that basically they came up with this whole concept. The original concept of Buildpacks does date back to like 2011 or ish, more or less. But the Cloud Native version that is Kubernetes native, that is for building OCI containers specifically. This project came up with this idea that this should be the idea of building OCI image should be a very structured approach. And what they did really is they came up with a couple of APIs, and they said, we're gonna provide an API for somebody for anybody who wants to provide like modules that know how to build your application and that can provide those base images that you need. So everything that you expect out of a Docker file, right? The from base image, and then your Maven package or your apt-get install or your you know, and somebody mentioned that they work with Jib. One of the things that Jib will do that's different from, like if you write a Dockerfile, you might just do a Maven package and you have your jar file, and then you just literally, you know, deploy your image to production with your jar file in it. Or maybe maybe you take that jar file and you copy it into an image without the JDK with only a JRE, but you're still copying the whole jar file and you put that into production. So one of the things that Jib was a tool that came out of Google that was for Java only. But what it did is you would compile your code on your computer as normal, the same like a Maven compile. But then Jib would take all those class files, and instead of taking the jar file and putting it into an image, it would organize your class files and say, okay, well, these class files are like your dependencies. You're probably not going to use those very often. You're probably not going to change those very often. And then it had some other kind of like levels of what it predicted to be like what you're going to change. And then the last one was, this is your actual code that you're writing as a developer. So you're probably going to be changing these files a lot. So what it did is it moved those files into the image as separate layers. Jib doesn't use a Docker file, but it's as if you had a Docker file that compiled your code and then had 4 separate copy statements, the last one of which would be a copy of your actual code, right? The first one would copy dependencies and so on. And so Jib kind of introduced that efficiency, and also because it copied things as separate layers, that meant that if you only changed your code, the rebuild is faster because you don't have to re-download or remove the main dependencies. You're just dealing with a little layer. And also the application starts up faster, right? An app that starts up from a jar file is going to be a little slower because it has to explode that jar file than if you already pre-explode all of those class files. So the efficiency was better. So Jib already introduced those things. So you could do that manually with your Docker file, but I'm going to guess, you know, like they're probably, I don't know that everybody's doing that. Probably not in Docker files. Yeah.
A couple things. We're gonna make a Java, right? And Java app, and so we'll be able to look at the layers later and demonstrate how it all looks. I think that's going to be helpful to really drive this home. Yeah. And then the other thing I want to say is when you're talking about the modules that make up the base image or the modules that make up the environment, those modules themselves can be called Buildpacks in addition to the logic that also is included in Buildpacks. So again, I'm just ambiguating again because that's what tripped me up when I was first learning this.
Yeah, like everything that you would have put in your Docker file comes from a Buildpack, basically. Whether it's that base image or whether it's all of the code in your Docker file. And that would be from, if we open the Paketo.io, that's an example of a provider of Buildpacks. Paketo.io website.
Yeah, how do you spell Paketo?
P-A-K-E-T-O. Like pack, but without the C for some reason.
Okay.
Yeah, so the Buildpacks project just came up with this idea that this is the way things should be done. Things should be very structured so that an image isn't so sensitive to the order of the layers as a Docker file, so that you can swap things out, so that we take advantage of the latest and greatest features of registry caching and of OCI image, the way that OCI images are composed, but the project itself didn't want to say, we're the experts in how you build a Java app, or we're the experts in how you build a Node app, or even like we're in the business of telling you which base image of, maintaining SLAs on vulnerabilities in your base image. The Buildpacks project is not in that business. Instead, what they provided was an API and said, here's a Buildpacks API. Whoever wants to be in that business, go ahead and implement this API. So Paketo is one implementation of the Buildpacks API. And so they provide all of these little modules of software that each there's one module that knows how to do how to compile a Maven application. There's another one that knows how to deal with a Gradle application. There's one that knows how to download JDK. There's one that knows how to build, to get the node requirements, right? All these little modules that work together in order to create the image for any particular application. And it is also the provider of those modules that provides you that base image that is that from statement in your Docker file, right? Whether it's the from statement where you might build your app, or the from statement where that you use for the app that you're actually going to put into your production system, right? That maybe has less things than the build environment. Where you look in CNCF lands, so Walid is saying, where you look in CNCF landscape, things are getting more depth and breadth. Wonder how one will keep up with all of this.
That is an age-old question, and if you figure it out, please do let us know.
I actually think, like, yes, the world is getting, there's like more options, and they're all getting more sophisticated, as you're saying, more depth and more breadth. But I also think they're getting easier to use. You know, sometimes I think about, like, I used to use this analogy even before Kubernetes for something else, but I think it applies as well to now, which is like, do you remember the days like in the office where like you would have like an old Cisco phone or a Siemens phone? It was impossible to use, and you had to learn to use like like how to look up somebody's number and how to get your voicemail. And it was like miserable. And then suddenly, like, the iPhone comes out, and the iPhone is so much more advanced. It's like an entire computer in your hand, but it's easier to use, right? Like the user experience is better. So I think that the same thing is happening in CNCF and this whole Kubernetes ecosystem, where if you look at, I mean, that's what Tonsil Community Edition is trying to offer, right? It's saying we recognize that the CNCF landscape is, there's more depth and more breadth, but we want to make it easier to use. We're going to give you packages, and we're going to give you a list of things that this is maybe your first go-to, and we're going to, you know, sort of consolidate the documentation. And I think that's going to be, I think that's a pattern where now that we've figured out all more like infrastructure topics, and, you know, Kubernetes kind of was like a way to reinvent all that stuff. The next sort of like step is, how do you make it easier to use, right? How do you reduce that learning curve? And
we're talking too, like from an ops perspective and setting it up and how it all works. But like once it is set up, it's watching your repo. Like you don't do anything. So if it's not your job to do this particular piece of it, then it magically happens in the background for you, just like all the components working in your phone that you're not actually thinking about.
Right. Yeah. We're wearing our operator hats right now.
Yes, we are.
A hat you may never have to put on. Correct. Yeah. So I am. Oh, you are the operator. Okay. Sorry.
Well, you signed up for this, friend.
Well, thank you, Wally, for making it easier for the developer.
Yeah, okay. Thank you. You're great, Rolene. We appreciate you. Okay.
So now if you're just a person on your computer and you don't need kpack, you don't need this thing to be running in a cluster, watching your repos and like maybe helping other developers, you could just use cloud native Buildpacks, which is what we've been talking about, with a CLI at your computer. And if you're going to do that, then you can just, you don't never have to wear that ops hat. You just go straight to the developer experience, and you can type, instead of Docker build, you type pack build, and you can say, I want to use Paketo Buildpacks or whatever. Heroku has Buildpacks, Google has Buildpacks, but you know, we're VMware, we like our Paketo Buildpacks. So also open source, but so you could do that, and you would build an image using this very structured approach. But if you're using kpack, you have to do an extra step. It does take like one step from an operator to do a little bit of configuration that you can otherwise avoid if you're just using the CLI experience. So shall we do that?
Let's do that.
Okay, let's do that. Okay, so basically we've installed kpack. And so, okay, so as we mentioned, we don't want to, even though we can't use the Paketo, the default Paketo is stuff 100% directly from kpack. We don't want to create our own base images, and we don't want to create our own logic for building applications. So we somehow want to like get the little pieces from Paketo and make them available to ourselves within kpack. So we need, if we think about our Dockerfile as like the base images, right? The from, if you have a two-stage Dockerfile, you would have two from statements, the from where you're going to do your app build, and the from where you're going to move your code to so that you can deploy that to production. So those two images that you use in the two from statements, that's your stack, right? That's your base operating system. We call that the stack. So we want to create, we want to make available like a stack to a base image for the build and a base image for runtime. And we're going to do that using the kpack CLI also. So just quickly before we do that, if you could type Cuddle space API dash resources, and then pipe, and then grep for grep kpack without the minus I. Oh yeah. Oh, sorry. That's just.
It's just habit to do them together. Yeah.
Please ignore that. Okay. So yeah, if we make that screen a tiny bit bigger, I think it'll be easier to read. Sorry, I mean, I like a tiny bit wider.
Oh.
So that like everything shows up in a single line, maybe.
Mm-hmm. Easier said than done.
Or just, or maybe just pull it left. Yeah, that's perfect. Okay. So we can see that these are basically the custom resource definitions that kpack is installing to the cluster. So these are the things that you have to work with. So since we're wearing our, cluster stores, cluster stacks, and cluster builders, exactly. So if we're wearing our operator hat, those are exactly the ones that we care about. Cluster, so stack is the base images, right? So our cluster stack is going to have a reference to the images that an image on which we can do actually execute the build of our app, and then an image that we can use as like the base for that runtime image that we're going to want to put into production. So that's our cluster stack. The cluster store refers to the modules of code that do everything else that you would write into a Dockerfile. So you would have, you have a Dockerfile for Java applications, you have a Dockerfile for Node applications, for Python, because each one of those has to have different instructions in it. So the store refers to the store of Buildpacks that have the language specific knowledge. In this case, the little module Buildpacks. And then when you have a stack and a store together, that's like saying, if you compare again to this Dockerfile idea, that's like saying, okay, I have my from statements and I have all the other statements. So between those two things, I have all the intelligence that I need to build my application image. I have to put those things together. So you put them together in what's called a builder. So that's what you can either make a builder that everybody can access from any namespace, or a builder that will only be accessible within a particular namespace. So hence you have cluster builder or just a namespace scoped builder. So as an operator, those are the things you care about. The source resolver is something that's created automatically by kpack to pull your repo. So you don't have to actually use that one directly. So yeah, does that make sense?
A couple things are, a builder versus a cluster builder is just, a builder is namespace scope, and a cluster builder will work across the whole cluster.
Yeah.
And then,
yeah. You could have a cluster builder for everybody in the org, but then like a builder that's only for your team.
Right. Mm-hmm. And then the other thing I have been kind of thinking of an analogy for all of this stuff. And so I think of like a test kitchen, and a test kitchen is being handed a complete dish of food, which is the code, the source code. And the test kitchen needs to reverse engineer that into a recipe. So the stack is the equipment, the OS, the equipment they have to work with in their test kitchen. The store is pantries, different pantries, maybe representing different types of cuisine. And so the ingredients for each different cuisine are available in that kitchen. You need to let the kitchen know. And then the chef who's reverse engineering it, that's the build pack logic, the process of figuring out, okay, from this dish of food, how am I going to make a recipe? That's what.
Yeah. I also like that we started with dessert first. It's a good one.
Yes. On brand.
But first, parfait.
I guess it's like for me, it's getting on dinner time.
Layers of food. Okay, so so let's use so you can do all of this with declarative. Yeah, you could write YAML for your stack and your store and apply that from a Git repo. That's totally fine, and maybe what you would want to do. But just because we want to illustrate the KP CLI on this particular episode, let's do this using the CLI. So what you would type, let's do the store first. It doesn't really matter. Now, one thing we have to do here is figure out. I think that I just want to make sure that we're not missing are you logged in at your, I don't think we need this yet, actually. Oh yeah, okay, let's log in. I think we need to log into Docker at your CLI. So let's make sure that you do a Docker login.
I'm just gonna.
And you're gonna need that value.
Yeah, I have it. I'm just gonna do it down here.
Okay, so we're gonna do a Docker login, and you can do -u and your -u Wiggity Whitney, and it should prompt you for your password.
All right. All right, we're good.
Okay, we're logged in at the CLI. Okay, so we did a Docker login. We're all logged in. Okay, so here, what you want to type is, so at this point, we're going to use the KP CLI, right? So we've installed kpack with the tonsil CLI because we were using tonsil Community Edition and the tonsil packages. But now that kpack is installed, now we don't need the tonsil CLI anymore. Now we're just in kpack land. And so from here forward, it's the same as if you would have installed it with Cuddle apply and created the, yeah, just as if you would have done it with Cuddle apply, basically. Yeah, and created the secret. So we'll do a KP space cluster. Let's start with a cluster store. Cluster store.
It's not case sensitive, I imagine.
I don't know, but I have it all. I do it all in lowercase.
Okay.
Save. So we're going to basically create a cluster store, and we're going to call it something. Let's call it default. Any name is fine. And here, because this is the store, so this is the intelligence that knows how to build a Java app, right? Or knows how to build a Node or Python app. So here, what we want to do is add Buildpacks. The Buildpacks are the modules that have that logic. So we want to say -b for Buildpack. And at this point, we want to reuse the ones from Paketo since we don't want to rewrite this logic. And so Paketo Buildpacks are kind of mirrored both on GCR and Docker Hub. So we can say gcr.io / Paketo-Buildpacks. And then / and let's say we know that we write apps in Java. So there is a Java Buildpack. And you can go to the GCR website and find these. Also, we were on the Paketo Buildpacks website just a second ago. All of these Buildpacks are open source, so they're all on GitHub. So there's information about all of this that's very accessible. But right now, what we know is that Paketo Buildpacks gives us this, even though it takes a lot of little modules to build the Java app, right? There's a Maven one, there's a Spring Boot one, there's a Tomcat one, there's a JDK one. They all work together. They all do a little piece of the puzzle, kind of like microservices, right? Each one does its own thing, but they work together. But Paketo gives us this, what they call a meta build pack, so that we can reference them all together. We don't have to name each one. So we can just say Java. And that will include everything. So we're saying we want all of the Java build packs. And then let's say we also, just in case.
I have a question. Does including all of that, what if I don't need all of that? Does including all of that make like a bloated image that?
I mean, I think at a certain point, you've got to make a call about like how granular you want to be. So what we're going to do here is say, and I don't know what apps we'll end up building by the time we're done with TGIK today, but let's get prepared to maybe do a Java app and a Go application. So we're not going to include Python and Ruby and .NET. So we are reducing the bloat of what the default Paketo Buildpacks builder would have. Like so in the other scenario we were saying, right? If you wanted to skip all these op steps, if you're just using the pack CLI at your command line on your computer, you could just refer to the Paketo Buildpacks builder that has already the Java and the Node and the Python, all those languages. So we are already reducing the size of that builder, but I don't know that. I think if you had a good reason to say I don't want the Gradle one in there, I only want Maven, you could do that. There's no one to say that.
Yeah. And then I would say too, the builder is used to actually make the images. So you don't have that many builders stored. You may only have one builder per namespace. If each builder can, if you're working mostly all in Java apps, this one builder we're making should be able to build all the Java apps, not just a certain, right? So it's not like storing, like all your images are all bloated with stuff they don't need. By the time you're getting down to the application image, not the builder image, then
yeah, and if you create a cluster builder, then it's actually a single builder that everybody can use across the cluster. But because these builders are, because you can put like, you know, Java Buildpacks, Go Buildpacks, and maybe you have your own Wiggity Whitney Buildpacks. So you could, maybe you want, you know, you don't want to share your Wiggity Whitney one. So you would choose a builder instead of a cluster builder. So then you've got the cluster one for everybody, and then with your special sauce. That, you know, so yeah, so let's add, okay, so then let's add another -b.
So just to, we have a question. So the Paketo level, just to reinforce, would bring down all of those resources.
So yeah, so the Paketo is going to include your, right now, we're just pulling the modules that know how to build Java apps, and we're going to add one to build Go applications. In fact, yeah, if you want to type that Go thing, I'll bring up the URL so we can, Java Buildpacks.
So should I press enter on this?
Yeah. No, same line, do a -b, copy that same GCR Paketo Buildpacks format, but then at the end, instead of Java, let's set ourselves up for the option to build a Go application. So just instead of Java, type Go. And
what have I done? It's hard for me to tell what's going on. Let me just pull this across. There we go.
Yeah, so, okay, so let's,
we're gonna choose a different.
that should execute. Yeah, we should be able to run that. And so in the meantime, if you want to go on the left-hand side back to the, yeah, hit it. Go again.
Go?
Go, yeah. Perfect.
And now enter?
Now enter, yeah. Okay, so and in the meantime, if you want to let that run, and we can go back to the web page and look at the Paketo website, paketo.io. I say Paketo, some people say Paketo, I don't know. But you can kind of see.
Let's call the whole thing off, isn't it? Sorry. It wouldn't be a proper podcast or stream if I didn't sing at some point.
Yeah.
Cora loves musicals, so we would all try to find a reason to break out in this song when we stream with her.
Everything's fun. It means so much more when there's music to it.
All right. Sorry to disrupt your thought.
So yeah, so if you go up, maybe try going to GitHub. Let's see where it takes us. Okay, so here, okay, so to click on the Java one, for example. So all of them are here, and if you click on Java and scroll down a bit, here's all the different individual Java build packs that are part of this like meta Java build pack. And so, and you'll see them, right? There's Maven is in there, Gradle is in there, the Belsoft Liberica is the one that brings in the JDK and the JRE. There's a Spring Boot one that does some special stuff if you're using Spring Boot. So, you know, different stuff. And so the process, the project itself will look at your application and it will decide which ones to use. You don't have to decide, but they're all there. And but this is the equivalent of like, you know, you having written all the instructions in your Dockerfile to build a Java application, except that here you're kind of relying on the team behind Paketo Buildpacks for their language expertise, so that you don't have to do that. So you literally can delete all your Docker files.
And there's a detection phase as part of the life cycle. So we're making a builder that will recognize Java and Go. But once it sees Java, will it pull down for a Java application? Will it pull down all of these, or just the ones that are needed for that particular application?
So what we're gonna do is we're gonna create an image that will contain all of these, and then when your application has to be built, that image will be used to create a pod. So all of these things will be in that pod, but the process will then choose which one of these to actually apply to your app code. So if you have a Maven app, obviously the Gradle build pack will be a piece of code in your build image, but you're not going to execute it. You're going to choose the process by itself will choose the Maven build pack, which means that that will add the Maven binaries, and it will be able to do the Maven package.
So your application image, if it's being built with this, if it uses Maven and not Gradle, it will receive a Maven layer, but it won't get a Gradle layer.
Correct.
So the bloat that we were talking about before is not there.
Correct. Yeah.
Cool.
I mean, yeah, just the code that could have done the code that can do a Gradle one for a Gradle app is sitting there, but it's not going to be. It's also not going to be in your runtime image. It's only going to be in the build image, so that will never make it to production.
And then we have a question.
Yeah. If it can't decide, then you probably report that as an issue to the team. There should be a reason, right, for which it can't decide. Yeah, I mean, if there's a case where like you think like there is enough information that the build pack should be able to make a decision, I would say in general that's probably an issue, right? It should be able to pick. And if it doesn't, it might mean that something that you're doing is outside of what these particular Paketo build packs support, right? They only know how to do what they know how to do, right? With the code that's in there. So if they go down the tree and they're like, we looked at your code, and like, for example, if right now we've only chosen the Go builder, the Go build packs and the Java build packs. So if you submit a Python application, it won't know what to do. And so therefore it'll just tell you, no, did not find any build packs that match your code. So it just won't do it, basically. Okay, so a couple of things just happened on the right-hand side of the screen. We said, hey, over there on GCR, there's this Java meta build pack with all these little things, and then there's also a Go meta build pack with a few different Go modules that we want. And what KP did for us is it said, okay, well, I know you want these. What I'm going to do is get them from GCR, and I'm going to copy them into your Docker Hub because you're using Docker Hub. And maybe that's a local registry inside your organization, right? But you don't want to have to be going out to GCR all the time. So it's actually made copies. And if you look at the output on the screen, when it made the copy, because we just said, hey, we said we want the latest version. All right, thanks, Waleed, for joining. Thank you for coming.
Yeah,
well, okay.
1:22 in the morning. Thanks for staying up
so basically what we said is I want the latest version of the Java build packs, and I want the latest version of the Go build packs, right? But probably within your organization, you don't want to be that like loosey-goosey, because like latest tomorrow might build something different than it did today, right? If Paketo build packs issues a new version of the Java build packs, then if you use them tomorrow and get the latest, there's not a lot of like reliability there. So for something like kpack, you're trying to avoid those kinds of scenarios. So what KP is doing is it's saying, I'm going to copy whatever's latest right now, and I'm going to move it into your registry, which in this case is Docker Hub, but it does it with a specific SHA. So now, from now on, until we actually update our store, we know that we're using what was latest on February 4th at 5:23 p.m. Eastern Standard Time, right? Mm-hmm. And so actually, if you go now to your Docker Hub website, you'll see those two images there.
Okay, I was wondering where it says cluster store created, where is the cluster store resource?
So it did two things. It created a cluster store resource in your cluster. So if you do a kube Cuddle get cluster store. And since there's only
it's not running in a pod, it's just a resource.
The cluster store is not, yeah, it's not running anything yet.
I see.
So we called it default, right? We said KP cluster store save, and then we named it. So there's default.
Mm-hmm.
And there you can see the images that are in Docker Hub in your account, Wiggity Whitney, and they have the SHAs in them, right? So this resource in your Kubernetes cluster knows about those two images that are now in Docker Hub instead of, they're not just pointing to GCR, right? They're pointing to a specific SHA of an image on Docker Hub. So if you on the left-hand side, if you open your Docker Hub, we should see that. Hub.docker, yeah. If you, yeah, just sign, yeah, you sign in and click on it. Either it'll take you straight there, or
it's gonna. So much. Well, I could probably. Yeah, cool.
Yeah, so TGIK, right? And that's what we said in the file. Remember? Yeah. So we said in the file with the 3 parameters when we installed kpack, we said we gave it Wiggity Whitney TGIK. So that's what KP is using. And so one of those is one of those two is the Java Buildpacks, and the other one is the Go Buildpacks. I don't know which is which, but that's what those two images are. One is the Java and one is the Go.
Cool.
So, okay.
And then
so now,
there's an OS Linux.
They're all those. I don't know where that info of that metadata is coming from. They're gonna all run on Ubuntu Linux images. I don't know where it's pulling that metadata out of to say that compatibility. It's probably in the metadata. I guess it's in the metadata for the original Buildpacks. So, okay. Now, so we have all of the statements. Now we're missing the from statements, right? We don't actually have the operating system yet. So that's called a stack. So, so let's do that. And again, we're gonna use the stack from Paketo because we don't want to be in the business of being responsible for choosing a base image and then following up on whether there's vulnerabilities and how we have to and like, you know, where we get a patch. We're just gonna say we're trusting Paketo to do this for us, and they have good SLAs, and so we're good. So very similar command to the last one. We're going to do kp cluster stack save, and then let's call this one, we can call it whatever we want. Let's call it base, for example. And then so now we want to do a -- build image. So going back to that build - image. So this is going back to that idea of a 2-stage Dockerfile, because you know you don't want like if you're building a Java app, right? You need a JDK to build your app, but you don't want a JDK in production. You just want a JRE in production, right? So you don't. So you want your build. More things have to be in your build image for you to create all the layers. But then you have a run image, which should be the same operating system, but it doesn't have to have all of the things. So we're going to say for our build image, we want to use, I don't know why I did it this way, but this one's going to come from, like I said, they're mirrored, right? I think on GCR and Docker Hub, the original Paketo stuff. So here we're going to use the one from Docker Hub for some reason. Paketo Buildpacks, all one word, /build : base -cnb, Cloud Native Buildpacks. So we're basically saying there is a build image that Paketo Buildpacks provides. We're going to use that. And we're just using, they have like a base, they have a tiny one, they have a few different flavors. We're just saying like kind of like your standard base one. And then and we want -- run - image. And we want same Paketo Buildpacks, all one word, / in this case run instead of build. And then base -cmb. So this is our Docker, our from stuff. So the from statement in our first part of our Docker file would be that build image, and the from statement in the second part of our Docker file, our theoretical, hypothetical, non-existent Docker file, is going to be that second one. But now Now we have the two from statements, and from the store, we have all of the other intelligence that you would have put into your Dockerfile. So once you have these two pieces, you can see how you no longer need Dockerfiles in order to do this. And yet everybody can be building images in the same way, leveraging, you know, the sort of expertise that went into all of the nuances about, you know, doing Java images or Go images or whatever in a good way, and also knowing where your base images are coming from. So yeah, we can hit enter. So same thing. Mm-hmm. Were you going to say something, right?
Oh, nothing. I'm just excited. I just like when things build. Just makes me happy.
When they work, yeah. So you can see here the same thing, right? It took, in this case, it did go from a Docker hub to a Docker hub, but it went from like Paketo Docker hub to Wiggity Whitney Docker hub.
Yeah.
So now we have 2 more images there. Yeah. So we have all of the things that we need to build, but we don't want to also pull down 4 different images, right? Or we don't have to be able to have to choose like, oh, I need the build image with the Go Buildpacks for this, and then I'm going to need the run image later. Like we don't want pieces. Nobody wants pieces of things, right? So we want all of these things to be delivered to us in one single image that's just easier to use. Mm-hmm. That's what a builder is. Not only that, but the builder also has an extra piece of software. Yeah.
Can I try to say it? Can I try to do it? You can correct me if I'm wrong.
Yeah.
The builder also, well, it contains the life cycle, right? But it also needs to hear the order. So if your company does 80% of applications in Java and 20% of applications in Go, then you want it to look for Java first, because that's going to save time in the long run. So when you have a lot of different modules of what it can be, you're going to supply logic for which ones you want it to look at first.
And you said it better, because I would have forgotten about the order.
Thanks. You flatter me. Thank you. I'm just happy to be here.
Exactly. No, so you're right. I would have forgotten that part until I would have looked back on my screen and been like, whoops, I forgot. But yeah, so let's define the order. So we're going to do the order in a file. So we need to create a new file.
Okay.
A new YAML file. So here the syntax is dash space group colon, and then enter, and then indent two spaces, dash space ID colon, and then Paketo dash Buildpacks / and then it's up to, I don't know, we can have a popularity contest. Does Go go first, or does Java go first? You choose. Does somebody in chat want to decide if we're doing?
Yeah, no one in chat. Oh, I don't think anyone in chat is responding, so we'll just do Java.
Okay.
If we hear differently before we save this file, we'll switch it.
Okay. So then you can literally like just copy those 2 lines.
Oh, okay. I was making it more work than it needed to be.
Yeah, another group.
Oh, you have to start group again? I thought group was all.
Go first. Okay, Conrad says, thank you, Conrad. Okay, so we're going to do Go first. So let's do Go first. Yeah, then you have to do, yeah, so because it's a separate group. Because you could do, if you put both of them in the same group, it would never build, right? Because no application would satisfy all conditions of meeting the qualifications for a Go app and the qualifications for a Java app. So you need these to be 2 separate groups, which is why we actually need to specify it in a file. If you only had one group, then you could put it in, you could put your various build packs. Let's say you added your own custom build pack and it all had to be one group. You could put them all in the command line, but we need a file because we need multiple groups. So it's either going to be, an app is either going to be Go, fit the conditions for Go, or it's going to fit the conditions for Java. Okay. So this is that's the file. We're good. So we can go back to the command line. And now we can do a KP, and let's make it a cluster builder, right? This is for everybody. So let's do cluster builder. Save, so same kind of syntax. And then we can call it builder whatever we want, but builder. And then we say -- tag. So here we're not, it's not automatically going to put this in that same TGIK repo that has all of the like subcomponents. Here we actually have the liberty of putting it wherever we want. So what we're going to say is Wiggity Whitney, like we still want it in Dockerfile, right? Because that's what we're logged into. Wiggity Whitney / and then, yeah, you can say TGIK -builder maybe.
Don't we want it in the TGIK folder on Dockerfile, or is it different?
No, I think we have it one level up from all the like subcomponents. Yeah.
Okay. Cool.
And then let me see if we need anything else. So we need to do KP cluster builder save, give it a name, -- tag, something. Okay, and then we have to say, okay, well, we're making a builder. We could have had 10 stacks and 10 stores. So like which ones? So we want to say -- stack. And we had given our stack the name base. And then -- store. That's perfect.
We don't need to give it. It already knows to look in my Docker Hub.
So remember when you did a Cuddle describe on the cluster stack? So it's using the resource in Kubernetes. It's the name of the resource in Kubernetes. Yeah.
Okay. Cool.
Base.
Got it.
Yeah. And then we want -- store default. And then that last piece that I would have forgotten is -- order. And then just the name of the file. So that's it. So it's going to make a builder. Oh, I guess it doesn't like the underscore.
I just tried to make it different so it wouldn't be confusing that.
That's going to be the name of the resource. I would leave it as builder because
builder just it's also a word that could be a command, so that's why I found it.
Okay, yeah, call it whatever you want. I guess it just doesn't take underscores.
Yeah.
Whatever you call it here is what you have to put is what when you have an application and you want to say I want to build this app, you got to tell it this builder. So this is the name that you're TGIK -builder. That's fine. Yeah. So yeah, so it's going to take, how do you check GRE and Go version of base images? So you can check it a couple of ways. One is to check the docs. So for example, if you click actually, Whitney on the left, if you click on Belsoft Liberica, the third one down. So if you wanted to know sort of ahead of time what's here, you can read about like through the documentation for the Buildpack, you can find some information, including there's actually an environment variable where you can modify it. Yeah, actually, yeah, probably going down to the configuration section is good. Okay, so this particular Buildpack includes 8, 11, 16, and by default, it's going to use 11, but you can, when you build your image, you can supply environment variables. Yeah, go ahead.
Also, after it's already built, you could use the pack command with the --BOM for bill of materials, and it'll show you in detail everything that's used to build your image. So we'll go over that later. After we build an image, we'll show you that.
So there's a question about a proc file, which I feel like I'm not the expert on proc files. I feel like it's
like a dependency declaration almost, except you're declaring all the processes that are running.
But I don't know if it's used. Is it used? I think there is a proc file build pack.
Oh, okay.
But I don't know if it was more of a Heroku concept, and I don't know if Tom is still here or if somebody else is still here who would know if this was more of a Heroku, like a hint to Heroku about how to choose build packs back in the day, or if it's something more native to a certain kind of application. I think it was Heroku. So so the idea of build packs before they became cloud native and Kubernetes and OCI image oriented, the idea of having these a process that would take your code and build your code for you was initiated by Heroku. And Heroku apps included a proc file, as I'm looking on their website, that specified the commands that were executed by the app on startup. So it was telling you how to start the app. So I guess if you needed to do that, there is a proc file build pack, but generally these build packs have enough intelligence in them that they know what would be the startup for like a Java application, or what would be the startup for a Python application. So I think that you generally don't need them, except maybe in special cases, in which case you would look to the proc file app build pack, which is more maybe for those edge cases. So I hope, Amira Amigo, I hope that answers the question. That's what I can tell. So, okay, where are we? We have our builder. Yeah, so let's check our builder on Docker Hub. Let's click over to the web page and make sure that it's there. Maybe refresh. Yay!
There it is.
So actually, now, like imagine you're at a company and your kpack operator has just built this TGI builder that builds Go apps and Java apps. Now you're a developer and you're sitting at your computer and you're just testing stuff. You don't actually want to commit code to GitHub and have this kpack thing that's on this cluster build your code. It seems like too formal. You want to do something more local. You can actually do a Docker pull on this TGI builder and you don't even have to do the Docker pull. Pack will do it for you. But if you have the pack CLI installed at your computer, you could just do a pack build and point to this Wiggity Whitney / TGI builder. You don't have to use the original Paketo one. So imagine if your organization had put maybe a little bit of added one custom build pack, right? Like in every app, we need to include this license file as part of the package. And so they would have added a Acme Corporation license file build pack. And so you need to use that. You can't use the Paketo ones off the internet. So at your computer, you could do a pack build and point to this builder without using kpack. And now you've ensured that all of your employees, whether it's a developer use case just at your computer with an imperative CLI, or as the app actually goes through the CI/CD toolchain through kpack, they're both using the exact same builder. So it's built into this mechanism of build packs, the ability to share across an organization or across the world if you're using the default Paketo build packs. And that's something that Docker is lacking. Docker files is lacking. It's something that Jib is lacking. So this is very powerful. Just the ability to deliver all of this intelligence packaged into an OCI image that is accessible to anybody with access, and that can be used by any tool that is compliant with this model, whether it's kpack or the pack CLI or the Spring Boot Maven or Gradle build packs. It doesn't matter which is the end user experience. All of those mechanisms can point to this builder at this point. Cool. Thank you, Tom. So, all right. So, Whitney, where are we going next? So I think we can
build an image with our builder.
Exactly. So we can take off our operator hat.
Yeah. Our developer hat.
Okay, yeah. In fact, before we do that, if you want, just on the command line, just to kind of show that point, if you type pack inspect, I think the command is inspect. Is it inspect builder? Maybe pack inspect help, maybe dash help, or pack inspect.
It doesn't have the builder image, so
maybe it's inspect dash builder. Let's try that.
Oh, well, then we need to supply it with the builder image.
Yes, we should. I don't know if it's a space or a dash, because I think that it's going to think that builder is the image name. So I think what we want to do is inspect dash builder. Does that work? Inspect dash builder, that's a command? Yes. Okay, so let's run that again and then add Wiggity Whitney / TGIK dash builder. Cool. So we should see our Java build packs and our Go build packs, and we should see if we scroll up. Yeah. Oh yeah. Perfect. Okay. So yeah. So we see Go and Java basically. And we see the order, right? Thanks to Conrad, we have Go first, Java second.
Mm-hmm.
And then if you scroll up a little bit, we should see our base images. So our run image is index.docker.io, Wiggity Whitney, TGIK, telling us where it's using the base image from. Mm-hmm. And a little, as we said, the lifecycle is in there, right? The lifecycle is that generic logic that actually knows how to use the build packs, because right now there has to be something that knows how to execute each build pack one after the other. So that's the lifecycle. We can see exactly which one it is. And so you can see here this combination of using the pack CLI with the builder you used in kpack. The fact that you built the builder using kpack doesn't matter. You could have built the same builder using the CLI, right? It's just different user experiences leveraging this Buildpacks project, basically. But you have access to some inspection because the pack CLI has some good inspection capabilities. So here's one. Oh yeah, okay, so yeah, Ivan says, let's build something. Okay, let's build something.
So we have, yeah. Great,
okay,
let's do it.
So let's build, okay, let me get you the command to build. Okay, so let's build a Go application because it's faster. I love Java, but Java's slow.
Okay. Is it still going to be interesting to inspect the layers of the Go?
Not that interesting from that perspective. We could build. Let's do two of them. Okay, let's do Java. Okay, so let's do. So you want to type kpack image create. Oh, sorry, not kpack. I'm sorry, KP. You were right. You're right. KP image create. And then whatever name you want to give the app, it doesn't matter. My app, whatever. Sunshine, perfect. -- tag. And here you want to give it the Wiggity Whitney / and then, you know, call it Sunshine so we know what it is. And then we want to say -- and here you could say either builder or cluster builder, but since we created a cluster builder, we want cluster dash builder, dash builder. Just to keep you on your toes.
Yeah, cluster dash builder.
Dash builder. And then here, whatever builder name we gave it, TGIK dash builder. So this is really, it's not really the name of the builder on the Docker Hub. It's the name of the Kubernetes resource. Yeah. Which was also TGIK dash builder, right? And then we want -- git. And so let's build. So I have a Java app. So you could type space HTTPS / //github.com / we can do C-Iberclyde. No spaces. Yeah. C-Iberclyde. C-I-B-E-R-K-L-E-I-D. Okay, nice. I like when people know how to spell my name. Thank you. / hello-java.git. And so we could, we could do a couple of things here, but I'm going, let me just check if I change this one to main or if it's still, okay, main, and yeah, so then the branch, so then -- git dash revision and space main. All right. Let's go for it.
Created.
Awesome. Okay, so it's doing its thing. So we can use.
It's not.
So we want
the thing is done. The image resource is created.
Yeah, the image resource is created. So you could do a KP image list, for example. And it says, okay, it's still working on it. You could also do a Cuddle get. I think IMG will work, or CNB images will work if you don't have to go through the KP CLI. So
Cuddle get images?
Yep, not images. I don't think images work. I think, oh, it does work. Oh, maybe, okay. You know what? I think you have services where you have to differentiate from K-native. Okay, awesome. And then, okay, so what happens? So let's go back and do our K API-resources grep kpack. pipe grip.
Yeah, sorry.
So, okay, so remember that we said there was a few resources that are interesting to operators, like the builder, the stack, and the store. So now as a developer, obviously we've done a KP image create. So we care, as a developer, we care about creating the image. The image doesn't actually do the work. The image is just there to say, like, I know that you want to watch this repo. Got it. Every time that there's a git commit, yeah.
I think so I guess it sounds like we're making the application image, but right now we're making, we're making a kpack resource?
Mm-hmm.
Yeah.
Yeah, we're just telling kpack, hey, I want you to make images from this repo.
Okay.
Mm-hmm. But the image is just sort of like that thing that has that information. It's not the thing that's actually doing the work.
So this is
a one-to-many relationship, right? One Git repo, many built images.
Mm-hmm. Okay.
So you have your singular image resource in Kubernetes that says, this is my app. And that image resource is going to spawn every time there's a Git commit, because we pointed it to the main. You can point it to a specific Git commit, and then we'll only ever do that one build. But since we pointed it to the branch, anytime there's a Git commit, it's a one-to-many. So that image will create a build resource for every Git commit.
So great. So we made a kpack image resource, and that kpack image resource is going to make a new actual application image every time that the main branch of that application gets changed. Cool.
Right. Yeah. And so you can see both the image and the build are custom resource definitions that are in this list.
Yes.
Right?
Mm-hmm.
So we've kind of covered all of these, right? We've covered the stack and the store, which are the subcomponents to make builders. We made a builder, which you could also have made a cluster builder. Those are, and the image is going to use the source resolver under the cover to pull Git. And for every time that it finds a commit to build, it's going to generate a build resource. How does kpack detect? It's actually polling, like every 5 minutes. It's actually polling. It has information about the last commit. And so it goes and it checks, it compares to see if there has been a commit in the last 5 minutes.
I imagine that's configurable if you wanted to pull more or less often.
I don't know, Tom. I know that it wasn't configurable. Tom can correct me if I'm wrong, if that's changed. I believe that it wasn't, at least.
Okay.
So,
I don't remember what we looked at before to show that kpack is a controller, but I don't know if this is correct either, but what my very limited Kubernetes experience is that anytime I read something as a controller, I think that it's a resource that's pulling something else. Is that a correct?
A controller is something that's within Kubernetes. It's looking in etcd to see if it's looking for things that tell it to do something. So like the controller is looking for an image resource. So when you as a developer say, here's kubectl apply or kp image save, here's an image,
got it.
kpack controller is going to see that and do something about it.
Cool.
So now that we know that we create one image and that one image can create many builds, we could do either a kp build list or a kubectl get builds. If you use the kp CLI, you'll always get better output because it's a little more customized to kpack exactly. But all these things are just resources. Oh, okay. So it failed. Oh no. All right, we'll have to figure out why it failed. So okay, so you can do a kubectl describe on the image. You can do a kubectl describe on the build. Let's start with those things and see if we can figure out what went wrong.
What's the image name?
The image, it's whatever we called the image. I think it was Sunshine. Or do kubectl images. Oh, yeah. So what is it telling us? Okay, it just failed 10 times. Okay, so let's see. We can do, we'll get to the pod eventually, but if you want to do a kubectl describe on the build, you could do that also.
And what's that?
So the build is the resource that represents the image has realized there's a git commit that it needs to build, and it's going to create this build resource that's in charge of getting that done. So it's like a middleman, basically. The image says, you go, I need to, a build has to happen. So it says, hey, build, I'm going to create this build, you get the work done. And the work is actually going to get done on a pod. We'll get there in a second, but let's go step by step. So you want to do kubectl describe build. And there should only be one build. So I think that should be enough. So it's waiting. So something is wrong. Okay, so let's see. So let's do kubectl get pods. So okay, so the build is like I said, it's like the middleman that's going to make sure that this thing gets done. But the work of doing the build is actually happening in a pod. So there's something wrong in our pod. So yeah, let's see. So it did successfully pull. What's going on here? Let's see. Pod waiting to start. So the pod is not initializing. Maybe it is worth doing getting. So the logs. Okay, so I don't think we're going to see. So okay, so here's a couple of things on the logs. You can, if you do it again, if you do that K, where's the output from the K get pods? Let's try that one again, so I can show you something. Okay, so you can see that, oh, well, it says, okay, you can't really see it yet, but there's like an initialization error. It's almost like it's having trouble getting started. So I don't think it's gonna work to get the logs, but you could try a KP build logs.
Since it's cluster scope, does it need some sort of authentication or anything?
I think we gave it the credentials to talk to, we made a secret, right? We created the secret, right? Right. Or did we skip that step? No. If you do a K get secret. We did. Can you run KP build logs? Yeah, let's do the KP build logs. So, okay, so the problem with doing a kubectl get logs. Okay, so it's, maybe we gave it the wrong information, or we did.
It's a Docker authentication error.
Verifying write access. So maybe, did we create that secret? The secret should be called, I think we maybe didn't create the secret.
That's what I feel.
Yeah, okay. So let's do, is that right? KP values. Let me check something here.
It's a push authentication problem.
So the builder. Wait, is that right, Tom? The builder should be using. Did we give enough information to the builder? Can you do kubectl describe on the builder? I think we didn't create the secret, but does the name of, I'm trying to figure out what the name of the secret would have to be. Let's see.
Yeah, did you make a secret in the default namespace? I don't think we did.
I think we skipped that step, yeah. So describe builder, describe cluster builder, TGI Kubernetes.
Okay, makes sense.
Yeah, I think we missed a secret. But wait, would it be here or would it be, let me see, did I miss it in there?
Should we grab for service account?
No. Where does the name of the, is it, I think we missed the secret. And like when I did this on my machine earlier, I called the secret regcred. I'm just trying to figure out if that should be the name of the secret. Like how can we verify that the name of the secret?
There's no service account ref. It's not referencing a secret.
If you do a kget service accounts, before kpack tries to start the build, it will attempt to verify right access to the repo. But what should, so yeah, let's do a k describe kpack default SA. But even with kp secret create, we have to give the secret a name, right? Should that just be reg cred? Describe service account. Should that secret name just be, like, how do we know what the secret name should be? Or it's, or actually maybe a kget service account.
Create secret using kp secret create. Are we in the default namespace now? We are.
So this is what I had typed before. So if we do if you save your, okay, so that token account, that token that you have, can you save it in an environment variable called docker_password? Not that token, sorry, your access token to Docker Hub, the one that you've been doing off screen. If you just if you create an environment variable, all capitals, docker_password equals, and then that value. And then if you want to take that off screen, then we'll have that.
Docker_secret all caps.
Docker_password in all caps. Docker_password equals, and then your token from Docker Hub. And then, yeah, if you want to hit enter enough that it's off the screen.
I want to make sure. Okay, and clear.
Okay, so then do a kubectl get service account default -o -o space YAML. So the secret name is this
default. This default token.
The weird thing is, when I've been doing this for my own test, I use the word regcred for creating the secret, but I'm actually trying to figure out where I got that information. Keep the secret to be. I've been using regcred. Is there any way, Tom, that it would be using something called regcred? Is there, sorry, was there another service account in the namespace? kpack. Okay, so what if we do the same thing but for kpack, like a get o -o YAML on that kpack default SA? Secret is so just for kicks, I don't know why, like just because it works on my machine, try doing a kp secret create regcred. I don't know if this makes any sense. -- Docker Hub. Okay. So space Wiggity Whitney. Yeah, and it should pick up. So that should pick up, if you have the variable docker_password set, it should pick that up automatically.
Cool. And now, yeah. So
now, so Tom, let me check actually the one on my machine. Okay, get. Let me here. Yeah, I have. So I have the kpack default service account that looks the same as that one. So what do we have to delete something and recreate something in order to fix that? That's the question. Why don't we try to, for now, I don't know if this would work. I don't really see the links for why it would work, but we can delete and recreate the image.
Well, should we check how?
We'll add the secret to the default essay automatically. Oh, okay. Okay. So then maybe we're good. Okay. So let's delete the image and recreate it.
Can we see if it's work? Wouldn't it maybe pull, like it's trying right now? So wouldn't it just?
But it has a limit to how many times it tries, and so I think, yeah, if you do a describe on, I think the build or the image, one of the two, it should tell you that it tried like 10 or 20 times by default, and it's like could give up. Build history limit.
Oh,
like, yeah, so it gave up at a certain point. So yeah, so we could delete it and then rerun that command.
All right.
Okay, let's try this again. Okay, so just talking about the logs. The reason that doing a get logs on the pod doesn't work is because the build is happening. The build, we talked about this piece of software called the lifecycle that was like injected into the builder image when we created the builder. Mm-hmm. That thing does the build and it follows a certain sequence of steps. And when this happens on kpack, every one of those steps is executed in a separate, like what's called an init container. And when you do a kubectl logs on a pod, it doesn't get the logs from the init containers. And even if it did, you'd have to like get them in the right order. So it's a more complicated kubectl logs command to get that information. So rather than write that complicated kubectl logs command, the KP CLI will do that work for us.
Okay.
With the KP build logs, that's what that does.
Oh, nice. That's great. Because then that's great.
Yeah. So we can do, yeah, so let's do a KP. We can do a kget pods and see how our pod is doing.
Okay. Oh,
we still have init error. You did delete it, right? Yeah, delete image sunshine. So yep. We can do, you could do we could do again a KP build logs. Oh, KP image trigger. I didn't know what that meant.
Instead of deleting and recreating, why don't we just rename this to something else? Rainbows.
It shouldn't make a difference. You can, I mean, if you delete it and recreate it, you should see that it's gone in the middle.
Okay.
The build would also disappear. Also the age, right? The age is 56 seconds.
Okay.
But we could do, but let's get the build. So KP build logs and the name of the image. So yeah, but I didn't know about the image trigger. That's interesting, Tom. So I guess you can just tell it to like rebuild. KP. Sorry.
That's my bad.
So it's the same. Same error. So if we do a K, if we do again, can we rerun the commands to see the service account and see if it added that secret? With a -o YAML. See the details. So, maybe the default one actually.
There's a reg cred there.
It is there? Oh, okay. Okay. So at least it added the secret. And definitely the so the question would be, are we 100%? And if you go off screen and do like an echo $sign.
I did that already.
Okay, it's definitely in there.
Yeah, that's what.
So why?
Oh, I'd be horrified if this was just because I didn't enter an environment variable correctly.
Let's see, why? Well, so it's still authentication. Let's yeah, I mean, I don't know. You can try to create a second image. It's the same. You can do the same commands, just a different image name. It'll create.
So when you do a cluster builder, your secret has to be in the default namespace.
So so the namespace that any developer is working in a namespace that the access role-based access control has to be defined in that namespace so that the pod there can actually log into Docker Hub and publish the image.
Right.
Because the pod is where the export is going to happen. So you need like all those permissions, and the access has to be per namespace. So we're working in that default namespace. So we need some service account in this namespace to have that information. And I guess, Tom, is it correct that it added it to the default? You're saying, yeah, KP secret will add the secret to the default service account. Right.
Yeah, that's what I was going to be my next.
Yeah, because we're not specifying a service account in anything. We're not saying, hey, image, use this. So it's using the default service account by default.
Yeah.
What does, I wonder, can we try that KP image trigger? Let's try the trigger in the Sunshine.
I wonder if we're supposed to supply it with Sunshine.
The name Sunshine probably.
Oh, so you don't have to delete and recreate?
So then I guess not. Yeah, I hadn't used it before. So if we do a build list, a KP build list now, I would expect to see 2 builds. And both are failing. So now you can do, so if you wanted to see the logs, I mean, I guess we're going to see the same error, but if you wanted to see the logs for the second one, it would be KP build logs and then the name of the image Sunshine and then -b space 2 because we want to look at the logs for the second build. So Martin, the name is Wiggity Whitney /Sunshine when we're referring to the image, the tag of how it's going to be published. So do you think, are you saying that we somewhere didn't write that? Oh, I see what you're saying. Oh, not good eye. Wait, good eye. Okay. Error verifying write access to Wiggity Whitney -Sunshine. Okay. Yeah. Okay, so let's go back and let's look at that image command again. It should be tag Wiggity. Oh my God. Okay.
Aha.
Yes. Martin.
Good job, Martin. Thank you.
I don't know if, maybe you have to do a KP image update or patch, but what is it? KP image help.
So
there is a patch command instead of create.
Okay. So same command, but then jump through.
Just go to the beginning. Yeah, and just say, awesome, Martin. Thank you. I would never have seen that.
Like that.
Oh, because it's a patch, so you don't need all that information. Blah, 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 whatever. You can also just delete it and recreate it. It might be easier because, since it's a patch, you don't have to write information that it. Just delete it and recreate it. It's easier. Wow. It might have taken me all night. I've seen that.
Do I need to do like the B1 and the B2?
No, just the image. So the image, remember that one-to-many relationship? So you're just deleting the one, and it's going to get rid of all of its descendants.
Oh, got it. Okay.
Yeah.
You can't change the tag on the image.
Oh, okay. Good to know. Okay, so we would have had to delete it. Okay, perfect. All right, let's rerun that.
That big long one? But with the right way. So we don't want the patch though.
We don't need the patch anymore. Yeah, right now we want create.
I should have, sorry. All right.
Okay, so we could do all the describes. We could just go straight to the pod. So you could do get pods, exactly.
Yeah, and it went out of 6. So the six, all those containers represent the different stages of the build pack lifecycle, right? All those inits.
Yeah, yeah.
So,
and I think we had it, the docs pulled up maybe that second tab. We were looking at the lifecycle stages documentation, I think, at some point. Somewhere.
We were.
Life cycle, yeah. So all of these stages, exactly.
So what's the non-logs command? I know the logs command to follow the logs for this, but what's the?
You could do kp build logs.
KP build logs and then sunshine.
Yeah, that's enough because there's only one.
Will it follow? Do I have to do a -f?
No, I don't think so.
Nice, cool.
Yeah. So awesome. Okay, yeah. So Whitney, you want to talk through the log file? So saved everybody like 3 hours of what it was.
Yeah. Thank you, Martin.
So yeah, Whitney, you want to talk through the log file?
I can't. So I know that it's going to go through these phases. And so it looks like it's trying to detect Bellsoft. So it's looking at JVM. So it's detecting whether we're giving it a Java, and then it must have figured it out because it's starting to download Java things.
So actually, if you scroll up, you'll actually see in the log file, there's like in light green, every one of those lifecycle stages has a label. So
I feel like I'm running backward, like the wrong way running on a treadmill, or like I think I can't fight the fast logs enough to scroll up since we're following.
Yeah, because this is so why don't we do this? Why don't you can you just do a different tab window?
Yeah.
And but you don't have that KP. Yeah, okay. So in a different tab.
I need to.
Or we can just wait for it to finish. Let's do this. I could give you like here. This is a different example. Can I give this to you on Slack?
Yeah. Yeah, or the private chat in our.
Okay. Yeah. Except I have that on there.
I don't have Slack open, but I can open it if that's where you have it.
Oh, I got it. Okay. So, let me just put Wiggy in here. Wiggy. Okay, I think this will work. Maybe.
Okay.
Get it.
Let's see if anything is lost in translation.
Also that finished, so maybe we don't need this, but
okay. It looks like it.
Can you scroll to the top, or is it too much for the buffer?
It's exporting, but it's not finished. It's just not as crazy, so we can see some stuff here.
Can you scroll to the beginning? Sometimes the window doesn't.
I mean, scrolling to the beginning is going to be. This is as far as it lets me go.
Okay. So, two things you could do using Tom's advice. You could do a KP image trigger sunshine, and it will rebuild it, and it will have less output because it already downloaded all of those Java libraries. So that would help. Or the other one I sent you was like a Go application. We could build a Go app that has less output also. You could do
build successful, so we can examine our image.
Yeah. So first of all, we should see, well, I guess the point of rebuilding was just to show the log file and to show that in the log file, you can see the life cycle.
Okay, what do I do?
So I think I would do the KP image trigger sunshine. I think that's probably the best way to do it.
Do it, sounds fun.
Cool, and now when we look at the logs, we have to add the -b equals -b2. Okay, so now
analyze.
Detect, now if you scroll up, exactly.
Yeah, export. You can see the blue arrows coming across.
Yeah, and if you scroll up to where it did the detect, you'll see that of all of the Java build packs that we saw before on GitHub, it chose 8 of those 19.
8 of the 19 are participating.
Exactly. So it knows about that it's a Maven app. It knows it's a Spring Boot app. And then after, so the analyze and restore is just like how it's using the cache to be more efficient, the cache and the previous image.
Yeah.
To not redo stuff it doesn't need to do. And then in the build, somebody had asked a question. I forgot if it was who it was who asked the question about the version of Java. So here you can actually see from your log file. This is a second place. So we said you can go to the docs to see what versions of Java are there. Here you can see that it used 11 by default, but also the Java build pack in particular is very good at this, at telling you like, oh, if you want to change that, that's the environment variable you can use.
Nice.
So each one it's telling, and then so every one of these, like in blue, Paketo Stift build pack, Paketo Maven build pack. So this is the stage where it's like applying. First it said, which are the build packs I need to do? And then it applies each one on the code. And so each one of these things has its own little script of like what it does. So you can see here also for the Maven build pack, the command that it's running is -d Maven test skip true package. So it's a Maven package, basically, it skip tests. If you wanted it to do tests, you can set that environment variable, BP Maven build arguments, and either take out that skip test thing or set skip test to false, and it will do the tests, etc. And then the process types are there, so I guess it doesn't need the proc file the way that maybe Roku might have needed it. Spring Boot, this is what you were saying about the slices. This is what Jib does. So Jib introduced this. This was an efficiency that you got out of the box with Jib, that Dockerfile, that you would have to manually do with Dockerfile, which was to precompile your code, organize it into layers, and copy them as separate layers. So you can see here creating slices where the dependencies, you might have like 100 megabytes of Spring Boot dependencies and like 10 kilobytes of your code. So now those are 4 different layers, and so if you just change your code, you only have to swap out. You only have to recreate that one layer. And this is the export, right, where it says, I don't need to use this build image in production that has the JDK or the whatever, go build stuff or whatever. We just need the app layers and the runtime. And then we should be able to see this on your Docker Hub.
Well,
if you refresh.
Yeah.
And then just as we did, so here's another image. Now this is an app image. And you can see also like the naming convention, right, of the builds. B1, B2 with a name stamp, so with a timestamp, so you know. And then,
yeah, okay.
Just as we did before, like we did last time we used the pack CLI to inspect the builder image, we can do a pack inspect for this image. From the command line. So
we have a question before we do our pack inspect. Is there a list of repositories supported by kpack? Does kpack only support Git repositories?
What kind of sources does kpack support? Kpack, I know that you can also pass it like it doesn't have to be polling Git directly. Like for example, if you were using some other tool, like Flux, for example, has something called a Git repository that polls Git, that can pull a Git repository. It can pull different kinds of sources, Helm repos. It can pull image repositories, different places where a source might come from. And then, so you could have a resource, or maybe you had like something before kpack that was testing code, and you wanted to pass the output of that to kpack. Kpack, I know, can also receive not just the plain Git URL with a branch, but it can receive it could receive like a blob, like if the thing before it had downloaded a blob that had all that source code, then it could just give it, and kpack would get that from wherever that it was stored, whatever claim that was stored on, and it would unzip that and build from that. But does it build from something that's not originally a Git repo? I mean, in theory, I suppose you could build build packs that process things that aren't code. So I guess, Tom, maybe Are there examples of build packs that are built to operate on things that are not Git repos? I mean, it doesn't have to be a Git repo, right? It just has to be code. But the build packs are going to look at what you give them and say, like, what is in here? If it's a Java app, if it's the structure of a Java app, all it cares about is that it's a set of files that represent Java code. It doesn't actually an S3 bucket.
According to this, the source configuration in your source image, you could do it from you can watch a Git, it can watch a blob, or it can watch a registry.
So yeah, so I guess, and if it's a registry, so maybe not S3, but people can also build using registry.
Yeah.
Yeah. When you use it with Flux before, Flux will produce a blob, and then you would use it with the blob instead of the repo directly. Yeah, but I guess not S3 directly. So maybe you would have to have, like, depending on what's in S3, maybe you would have something like a Flux that can monitor S3, and when it sees a new thing in the bucket, it would maybe turn that into a blob. So I guess you need like S3 is a blob. Okay, so you could use so you could put the S3 path directly, Tom, you think, in the blob?
The blob either needs to be publicly accessible or have the access token in the URL.
So it sounds like yes?
Sounds like a yes. Yeah. All right, so ready to dive into this image?
Yeah, let's do a KP inspect. Sorry, let's do a pack inspect. Wiggity Whitney Sunshine. So here, so this is also very cool because you can't do this with an app that was built with a Dockerfile, right? And so what do we know? So if you're an operator and there's a bunch of images, now they're not just sort of these like unknown black boxes. Now you can look inside and say, oh, I know exactly what was used to build this. And there's a second level of information. But it's a little more convoluted to get it, but I can figure it out.
No, it's BOM. It's 2 dashes.
Yeah. So, but I think what happened is I don't think that's going to get you results right now. Yeah. So that BOM flag will work for an older version of the build pack, I think.
Oh,
but newer build packs are changing so BOM stands for bill of materials. So it's going to tell you. So basically, the inspect told us information of the life cycle. The life cycle knows what's the list of build packs I used and what versions and all that. What the life cycle doesn't know is what did the Maven build pack put in here, or what did the Spring Boot build pack put in here, or what did the Python build pack put in here, right? So for that you need something called bill of materials, which is extra information about what's in the image that each build pack has the opportunity to contribute. And that used to be accessible by just adding --BOM. But what happened is that currently what's happening is that the bill of materials process is becoming more structured. So now it's a SBOM, structured bill of materials. Oh. And I think there's just like, we're just in a point in time right now where it's not as easy to get it with a single command, but I have done this. So there is a way to get it. Okay, so it'll be a little typing. So let me actually just put this in this for you. Let's see if we can get it to work. So you kind of want to copy that command, but we'll have to change a couple of things. So this is a little hacky way to get all this extra information out of the image for now. But this information is accessible like a scanning tool, right? Okay, so we want to change it to the name of the, I think you probably, instead of IT, Wiggity Whitney.
Do we want to take out the IP flags?
No, leave everything else in, just the name of the image. I think that should work. So it's going to pull the image down.
Wait, why is it so much harder than it used to be? Like, will the easiness be built back in?
That's a question for Tom. I hope so. Will the minus BOM flag be replaced by like a minus SBOM that will make it easy?
And that's a cloud native Buildpacks level thing. Maybe Tom just knows because that's his job, but that's not a kpack thing, right?
I mean, that's a pack thing, I think, because the pack's the live one. It's stored in a layer now instead of the label, because there's a character limit on labels. It's stored right now. It's part of the image. It's like contents in the image instead of metadata on the manifest file.
So now that it's cool, I can do it.
Now, okay, so now what you want to do, so the command that you ran before, if we look at it more carefully, what it was is that we said, what we want to do is really that thing that's kind of on the right that says Docker CP. What we're trying to do is copy this layer out of the image and just copy those files on the layer in the image. But the only way you can do a copy on Docker to get a layer out of the image is to run the image. So we had to do a Docker run first. And then we just we ran it, copied this layer, stopped it. So so now on your disk, you should have /layer/ structured bill of material /launch. So we could do a cat on one of those files. So cat, and then you should have a launch. You should have a directory called launch now. Launch or layers. Launch. Okay. And then so if you tab, you'll see how many files are in there. So for example, let's look at the Bell South Liberica one. That should be interesting.
Okay.
There might be other reasons, says Tom, why Cloud Native Buildpacks moved it, but that is one thing that was causing issues as Buildpacks wanted to add more information. Okay. So so as Tom is saying, one of the reasons it changed is because, yes, Chengjian, yes, we can show that as well in a second. So so you have to keep going, keep tapping until you get to the file name. So let's do JRE, let's say. So remember, this is the runtime image. It's not the builder image. So there's no JDK in here, right? Just this. But now we can see it's exactly. So as an operator, suddenly I'm like, I know what's in here. It's Java JRE version 11.01 from, whoever this is from, like, right? You know exactly what it is, as opposed to not knowing or everything built by every different Docker file being different, right? The other one that's interesting here is the Spring Boot one.
Okay, let's check it out. And
I think because it's JSON, you can also do, I don't know if you have JQ, but if you can do, after you find the Spring Boot one, you can do a pipe and then JQ if you have JQ.
Do you want to do bindings or helper?
I think the bindings probably. I know it's in the helper. And then, or maybe not, maybe the other one. Maybe the
other one.
Yeah, I don't know what's in each actually.
Fair way to.
Or maybe that, Well, maybe that info is going to be added back. I don't know. Normally when it was a minus BOM, you could find all of the library. So maybe it's just in a different. Maybe there's another layer in there that has that information that I'm looking for. But yeah, so let's answer Chengjian's question, which is yes. Oh, but you might not
have work with images built by kpack.
Yeah, so you may not have. Do you have Dive installed? If you do Dive or which Dive?
No.
Okay. I don't know if it's to install Dive. Let's see. We can try that. Is that what? And actually, Chengjian, you can do it because that image is public on Whitney's Docker Hub. So you could do a Dive on the image yourself right now. Okay, so let's do Dive and then Wiggity Whitney. I don't think, yeah. So, okay, so dive is basically a UI in the terminal to look inside of the image. But you can see, okay, so what I would do here in dive is I would hit tab, and then I would hit Control U, hit tab once so that you're on the right-hand side.
Okay.
I think, are you on the right-hand side?
Yeah, there's a big dot.
Oh, you're
on
right.
the right.
Perfect. Okay, sorry, I was looking at the
Control
purple.
U.
Control U. Okay, and then tab again. So what that did is basically it said, so on the left is a list of layers in the image, right? Because OCI images are a list of layers. And on the right-hand side is the contents, but we don't want to see all of the contents. We just want to see what's different from layer to layer. So now you can just kind of like hit down and you can see the structure of the images of every layer is really well structured and they're all uniform, which is part of what makes it possible to not be so sensitive to order as a Dockerfile would be. These are, you can see that here's a layer added by the Belsoft Liberica build pack, right? Et cetera. Like they're all, and so that thing we were talking about, the layers of the app itself is probably a little lower down. I would guess that it's a 19 meg, the one that's 19 megs, that one probably. That is all, yeah, those are all the Spring Boot dependencies. And if you would just jar it all up, in maybe, you know, most of Docker files, if you just jar it up, you would have like, you know, 19 megs plus your 242 kilobytes plus 0 kilobytes from snapshots plus your 10 kilobytes of your code. All of that would be one jar file. And if you change like one line of code, you have to repackage and retransfer all those 20 megs, which this is a tiny app, right? Probably that's more like 100 megs or more. But if you do it this way, you change a little code and that's the only thing that changes. That's the only thing that's also retransferred over the network to your registry or from your registry to where you need the image.
That's huge. The dependencies is like the big pudding layer in the middle. It's like a lot of it. And so if you don't have to take all that out of our parfait, that's great. And then rebasing is similar too, like with the log4j. Let's talk about this. Talk about that.
Yeah, we didn't do that. So yeah, so rebasing. Let's do the rebasing.
We're gonna rebase ourselves. Cool.
Yeah, we can rebase. Okay, so rebasing means it's the equivalent of like, what if you realize that your operating system is bad and you have to change the from statement in your Docker file? You just have to rebuild the whole image. So we don't want to do that. We want a better way. And so what that looks like in kpack, let's say, is okay. So we're getting our we kind of like outsourced our concern about the OS to Paketo, right? We're getting the stack, the operating system from Paketo. So we would expect that when there's some issue with the operating system, like a Heartbleed or Spectre or whatever, one of those big deals, that the Paketo team is going to get into action and issue a new version of the stack. And all we have to do is go get it and then patch our systems, right? But patching our systems, really, in this case, we don't want to have to rebuild all the images. We literally want to take out that OS layer and say, here's a new OS layer, and just have all the images point to it. It should be really fast. So in order to simulate that, we want to use the kp command to change our store. So let's do that. So we do kp cluster stack, save, and then remember the name of our stack was base. And so we say -- build image, and
build image.
What we had before was Paketo Buildpacks, all one word, /build, and then
what? I'm sorry, I missed it. What /build?
/build.
Okay.
Paketo Buildpacks /build, and then colon. And so here the tag is the version, right? So before we had base CMD, so we just got the latest one. We're actually going to go backwards to simulate this, but pretend we're going forwards. So instead of getting base CMD, we're going to specifically say version 1.1.39,
When I'm typing the word version or no?
Oh no, sorry. Just
yeah. 1.1.39
dash base dash CNB. And then the same for minus run image.
Just copy paste it.
Yeah, Paketo build. Yeah, exactly. Well, instead of build, it'll be run in the middle. But yeah.
Okay.
And so that's really all we have to do. We just say, hey, it's a new stack, and kpack will do all the work. It'll say like, oh, new stack that affects this builder. This builder was used for this application. And so for this application, I'm actually going to go and update the metadata, the manifest of the app, and say this thing that was pointing to the bad OS layers that had a vulnerability, I'm just going to update that pointer and point to this new OS layer of version 1.139. And I'm not going to touch the other layers. I'm not going to recreate the layers. I'm just going to leave them the way I'm going to point to the same things. So it's super fast and it's very non-invasive. And you can see evidence of it in the log file for that particular build. It'll look quite different from the log file for this statement is true only for Paketo provided OS layers. No, this statement is true for, well, this functionality and this concept comes from the project itself. So any Buildpacks that are compliant with the Buildpacks API should be able to do this. So this is a project concept that Paketo is merely implementing. Of course, you know, you have to, Paketo as an implementer of this concept, Paketo is guaranteeing that the base images are compatible, and Paketo is doing the work, but the idea and the requirements comes from the project itself. So in theory, any Buildpacks should offer this functionality. Yeah, the idea is in the project itself.
Mm-hmm.
So we could do a KP build logs. If we do a KP build list, actually, we can verify how many builds we have. So 3. So we want to say, and actually you can already see. You see how it gives you a reason? So there was a success. There was a reason config, which was the first time. Then we did a KP image trigger. So the reason for the rebuild was a trigger. And now we changed the stack, and it's telling us this is a stack. So that's a hint to us that that's probably not a rebuild. That's probably a rebase. So if we look at the build logs for build 3, that should confirm that suspicion.
So I have to do Wiggity Whitney Sunshine V3?
No, just Sunshine, because you're really looking at you're putting the name, not Wiggity Whitney. Wiggity Whitney refers to the image on the
yes, sorry.
registry. So you just want the name of the resource in Kubernetes.
Gotcha.
But you want build 3. Oh, so this is, it's giving you the latest one. Oh, that's awesome. Oh, cool. Oh, so you don't even have to do that. Okay. So build bugs gives you the most recent one. So, but you can see this is, there's no analyze, detect, build, export, restore, whatever. It's just rebase and then completion. But it published a new image to the Docker registry. And this would do it like, to all if you had thousands of images that you had created, and this kpack installation was managing all of them, within, a few seconds or a minute or a couple minutes, it would rebase all of the images. And then all you have to do is reapply them to your cluster, which is the most efficient way to get rid of these operating system vulnerabilities, as compared to kind of status quo of in a non-container based environment. You would have to coordinate with the development teams, take down the operating system, upgrade the VM. But even with Docker files, you'd have to run through from beginning to end, rebuild your entire image. So probably also retest it and all that stuff, right? And do each one imperatively, as opposed to kind of like at scale, just like an octopus, right? Like all of these, rebuild, rebase them all.
A very powerful octopus.
Yeah.
I like that mental image.
Kpack. It's got its tentacles in all of your images. So, Tom, do you think that there's anything important that we should be showing that we missed?
we have covered everything that we set out to cover. Does anyone have any questions? Or does anyone, yeah. Or yes, Tom, is there anything you feel like you'd like to see?
I know there was a question earlier by somebody about Maven and Gradle. So the equivalent for that would be if we had cloned, like our Java app that we're building here. Now, so if we were to clone that onto Whitney's machine, we could either do we've already seen we can build the image using kpack. We can also clone it and do a pack build, or we could clone it and do a Maven Spring Boot build image, and it would be this. Oh, yeah. Oh, so that was the previous question, right? Yeah. So you could do. Yeah, if we were to clone that repo, we could literally do Maven build image, Spring Boot build image, or the equivalent Gradle command. And it would use the same cloud native Buildpacks. You would see the same output in the log files. You would use you could use either Wiggity Whitney builder or the Paketo original builder. And
it would build the exact same image in the exact way. It would be identical. Yeah.
Exactly.
And we had the question.
If you build it with Maven, even if you build it with a Maven, you can still inspect it with Pack. Right? They're all
and die. Yeah.
And die.
And this one was way from the beginning that what we said we'd revisit it.
Okay. So yeah, so the one so it's very different from Canico. Canico doesn't use, but what I wasn't sure is if does Canico use Docker files? If Canico is a way to execute a Docker file. Canico is a tool to build container images from a Docker file inside of a cluster. Okay, so yeah, so if you're using Canico, you wouldn't be able to get rid of all of your Docker files. It would just be a way to, instead of using Docker build, and you could do it, Canico would basically do, because when you do a Docker build, what's happening is that the Docker build CLI is not doing the work. The Docker CLI is just handing your source code and your Docker file up to the Docker daemon. And the Docker daemon is doing the work of executing every line in your Docker file and producing the image. So if you're in a Kubernetes cluster, that doesn't really work because you don't have Docker there to do that heavy lifting for you. So Canico gives you that sort of backend that you can still give it your source code and you give it the same Docker file, and Canico will execute the Docker file for you and produce the image. So it's a way to use your Docker file without the Docker daemon there, but you're still using a Docker file, right? You're still writing that custom script. You're still, have no mechanism to share it across development teams to sort of, to have this better structure, to have more, just a better quality image and a better structured image in a more inspectable, more transparent, all the great things that cloud native Buildpacks could do. So Canico is still Dockerfile.
Amero Amigo called you the Bodhisattva of Buildpacks. I love that.
Both of us. That sounds good. Thank you. I'm going to Google that.
Does the kpack builder require root privileges?
No, it shouldn't. Right, Tom? Can you confirm that? But it should not.
No. Does it require, what is the, does it require, is it using the runtime that's on is it using the daemon, like whatever container daemon in your Kubernetes cluster?
So when you use pack build and the builder, if you're going to use cloud native Buildpacks using the pack CLI or Maven or the Spring Boot Maven or Gradle plugins, then on your computer it will use the Docker daemon on your computer to do that build, right? It's going to use that builder image. It's going to run that builder image somewhere, and inside of that builder image, it's going to build your code. But when it's on Kubernetes, it just uses that pod. Everything is happening inside of that pod. Every stage of the life cycle is in a container inside of that pod. It does not rely on the Docker daemon. So there's no sidecar Docker or anything like that. And since this is just building an image, it's not actually running your image, right? This is just, here's your image in your registry. You then have to do the Cuddle run or the applied deployment, and that's going to use the runtime in your cluster, right? But kpack not itself. So okay, so Tom, thank you, Tom, is confirming no root.
no root privileges needed for the kpack builder.
I have to say, I'm so grateful for everybody who's, I mean, this has been long, right? It's like almost 2 hours. So yeah. Thank you to everybody who's stayed this long. All of the questions that we've gotten, Martin, that like critical help. And Tom was like a developer on the team who's so kind to be here throughout to make sure that we didn't get stuck anywhere and you know, just be there with extra expertise should we need it. Thank you so much.
Thanks to everyone in the future who watches the replay too. We're grateful. Yeah. And we're available. I think both of us are available. We have our Twitter handles and in fact, let's stop sharing screens. We'll talk a little bit. We have our Twitter handle, so feel free to DM either of us with questions. Let's be real. You're going to DM Cora. No. If you, I mean, I really, we talked about like helping with proposals for coupon or coupon related things. I will be less knowledgeable, but I am. If you need a pep talk, I'm very good at those.
And she's underselling herself. She's super smart. She's moving out really fast, and she's really very courageous in putting herself out there and helping others learn and making it relatable and asking great questions. I mean, the ability to ask great questions says a lot about you know, the clarity of your thought and your curiosity. So don't undersell yourself.
Yeah. Well, it's been wonderful. Thank you, Cora.
Thanks, everybody. Thank you, Whitney. It was fun to do this.
Have a great night.